class, we just discussed regarding few numericals associated with the moment distribution method. So in this class, we are just continuing whatever the remaining MCQ questions. Okay. So just to take the 14th question. What is the value of moment distribution factor for joints B and C? What is the value of moment distribution factor for joints B and C respectively? Yes. What is the joint distribution factor for this case? So I'm asking the moment distribution factor for joint B and joint C. So how to compute distribution factor? Now we know that. So distribution factor at fixed support is 0. Here we are having overhang. Here also 0. But we are getting B and C. It's the intermediates. For B, we are having BA and BC. For B joint, members are BA and BC. And for C joint, the members are CB and CD. So what is the relative stiffness for the members? Here, if the end support is simply supported, then that is called 3I by L. But here the given problem, which one is the end support? Here, what is AB? AB is 3I by L or 4EI by L? BC, CD. Here in the given problem, CD is, here you are ignoring the overhang since CD is simple support. So this is 3I by L. For remaining all, 4EI by L and 4EI by L. Try to work out 4EI by L. Try to work out what is the answer. For EA, 4 into 1.5. 4 into 1.5 EI by L. 4 multiplied by 1.5. So we are getting 6. 6 EI by L. L is 6. 6 get cancels. For BC, 4 EI by L. Once again, 4 EI. EI is 1 here in BC. So L is 4. 4 get cancelled. So if you do, you are getting 2 EI. Hence, the value is 0.5. That is 1 by 2 is 0.5 and 0.5. So if you observe the answer, here there are two options, A and B. These two options will eliminate because for first two members, BA, BC, it is 0.5 and 0.5. So these two answers are eliminated. The remaining answers are A and B. So we have to find regarding CB. For CB, once again, this is EI, 4 EI by L. For 3 into 2, 6. Here, 3 EI by L. 6 by 4. We are having 1.5 EI. 1.5 EI. Sum should be 2.5 EI. So 1 by 2.5. So 1 by 2.5 will give 0.4. So if it is 0.4 and the other one will be 0.6. Which one is the answer? 0.5, 0.4, 0.6. Which one is the answer?
C. Option C.
Option C. So this is very, very important question. Any doubts?
No, sir.
Okay. We move on to next question. All members of the frame will have same flexural rigidity. If you consider a frame, it's having same EI value. I is constant and length is also same. I and L are same. If the moment applied is at joint M, the rotation of the joint is. So here you're applying M. What is the T value? What is theta B is asking? What is the theta value? So the thing is, what is the relationship? K equal M by theta. M is given as M only. So theta equals M by K. Now determine K. What is AB? K value for AB? 4 EI by L. This is also intermediate. 4 EI by L, but this is simply supported 3 EI by L. If you do this sum, you are getting M divided by 4 EI by L. L is L only, plus here also 4 EI by L only. All EI are constant. So this is 3 EI by L. 3 EI by L. 3 EI by L. So we are getting theta equal M divided by 4. You take LCM L. So 4 plus 4 plus 8, 11 EI. 11 EI. Right? So if you take, we are getting ML by 11 EI. This is theta B. Having an option. Is there an option? ML by 11 EI?
B. And B.
B answer is, that is theta B is ML by 11 EI. B. See, these are very, very important type of questions. Must be careful while solving these kind of questions. See, we just look the answer. Answer is B. ML by 11 EI. ML by 11 EI. Any doubts? Any doubts? Friends, are you getting? Okay. The frame subjected to forces as shown in figure. The shape of BMD is. So this is the given frame. What is the expected shape of BMD? What is the expected shape of BMD? What is the expected shape of BMD? So try to write the shape of BMD now. Okay, I will give the option. So what is the expected shape? Try to find the expected shape. Which one is correct? Try to guess. Here also you're having hinge support. And here also you're having hinge support. So we know that at hinge, the moment is 0. At hinge, the moment is 0. The hinge, the moment is 0. The hinge, the moment is 0. So if 0, the final moment is expected like this here. Here also the final moment is expected like this only. Like this only. Like this only. And here we can expect, here we can expect a general shape. I'm trying to write. Here we can expect because of load. So this is the possible moments of final moments, whatever I am representing, that is MAB, MBA, MBC, MCB, MCD, MBC. But here hinge, because those two are 0. And if we impose the whatever free BMD, here we are having triangle. So because of point load, we may expect like this. Because of point load, we may expect triangle like this, triangle like this, triangle like this. And this value is WL by 4. And we may expect a parabola because of UDL. We may expect parabola because of UDL. We may expect parabola. If you hatch, you can look like this. Sometimes they will hatch for all the members. So which option is correct?
C.
Option C. So generally this value is WL square by 8, and this is whatever A, B, C, D. It's our final moments. So this kind of direct BMD is also expected. Direct BMD is also expected. I will give 1 or 2 question more. You just try to find BMD because it's very, very important concept. Very, very important concept. Now, What is the shape of BMD? What is the shape of BMD? What is the shape of BMD? See, if I consider a vertical member, here I am having fixed. So if you are having fixed means it is also having ability to generate moment. So this member is also having ability to generate moment. So it's the kind of like this kind of BMD. Any doubt in AB element? Any doubt in AB element? Any doubts in AB element? Next, if you consider BC, it's also intermediate. It is also having ability to create this kind of BMD. If you consider CD, if you consider CD, this is having ability to consider moment, but this will not have because this is hinge support. And here I am given UDL all kinds, so all UDL will generate a parabolic. All UDL will generate a parabolic curve. All values WL square by 8, WL square by 8, WL square by 8. Any doubts in BMD? Any doubts in this particular problem? Now, what I will do, I will remove this load. So by default, it will get removed. If I remove this load by default, this particular thing will get removed. Okay. If I add this force W, then immediately if I W point load, the triangle will comes into picture. If I add, so any kind of what? Is any doubts? So if I add one more W, then your diagram will be like this. So this is another case. If I remove this, then it will get removed. If I remove this hinge support and I will add a fixed support, then what will happen? The member will get replaced like this. This is the column. So here is also moment is possible. Here also moment is possible. Look like this general BMD case. And if now, if I remove this UDL, so this whatever curve get removed. Okay. If I add somewhere here the point load, then it may look like this. So it's a general type of BMD. Clear? Any doubts? The only chances are you are getting different support condition. They may change the support condition to hinge or roller. Hello, if they're doing hinge, then what happens? Then it will get, the support will get zero moment. So that's why what happens if it is hinge? If it is hinge, then it is zero and the moment is like this.
Sir?
Yes?
So can you please explain it again, sir? Once again, like how does the bending moment diagram comes?
Okay, ma'am.
Yes, sir. Thank you, sir.
See what happens in generally frames, they will ask bending moment diagrams because students are getting most confusion in frames. Okay. So the general thing is there are two aspects you have to focus while you are writing a bending moment diagram in case of these kinds of frames. One is support condition. Support condition. See, when why I am telling this support condition, if you are getting, see this AB is a member, like it will interconnected to BC, it will interconnected to support, supports directly. By default, I can say that this B and C, you know that by joint equilibrium condition, both will experience the same moment. Both B and C will experience the same moment. Hence, if I write the bending moment diagram, general bending moment diagram, MEAB, MBC, all those things, you are getting moment here. You are getting general moment here like this for BC member. But while you are considering AB member, I have not assigned the joint condition here. Please observe. And also for CD member, even I have not assigned for joint condition. But I know that this BA will experience a moment. This BA will experience a moment. This BA will experience a moment, and BC will also experience a moment. But depending on the support condition, A and D will decide. If I am imposing fixity, if I am imposing fixity, it will get a moment. It will get a moment. So this is the shape of BMD. This is the normal shape of BMD. If I am imposing a hinge, or roller or simple support, it won't take any moment. That's why I will connect it to 0. I will connect to 0. Now, this is regarding a frame moment. This is dead load moment of the frame. It's a simple frame moment. If I am imposing some loads, say UDL, what is the shape of bending moment for UDL? What is the shape of bending moment diagram of UDL?
Parabolic.
So present parabolic. Now I am imposing a point load. What is the free bending moment shape of point load?
It's a triangle.
Replaced by triangle.
Yes, sir.
That's all. Here there is no load. There is no moment diagram.
Okay, sir.
There is no moment diagram. So there are two aspects. One is support conditions for frame moments. Support conditions plays a major role for frame moments. Another one is member loads. Member load for different pattern, parabola or point load. Generally, parabola or triangle. So two things they will regularly ask. Now you can see this particular problem. Now just tell me how told two important points. The first point is support condition you have to observe for frame moments, right? Support conditions for frame moments. First, take a frame. First, you consider a frame. You know that this is intermediate. These two joints are intermediate. You are getting a moment, right? And also you know that this also will get a moment. This will also get a moment because intermediate. But these two depends on support condition. Here, which kind of support? This is which kind of support?
Hinge.
Hinge. This is also hinge. Hinge will get a moment or not?
No, sir.
No, sir.
It won't get. So 0, 0. This is hinge. This is hinge. Now write the member. Next important point is member moments. Member moments or member load moments. Imposed load moments. Here, what's the load imposing? 10 kilonewton. Which kind of load it is?
It's point load.
Point load, which means
Triangle.
you are expected triangle. Here, you are expected parabola. Parabola means because UDL. Here, there is no load. There is no BMD. Clear? Now, we will just see the answer. How it will look, which option is more suitable for this given condition. Which option is suitable for given condition? Which one?
Option C.
Option C. That's all. Now, what they will do sometimes, they will give a diagram. You have to guess loading. Please guess which type of load is responsible for this. Please guess which type of the loading is responsible for this.
Yes, sir. UDL, first one is UDL loading and hinge support.
Yes, UDL. Here you may get UDL loading. You may get 0. Sometimes you may get 0 moment. It depends on given value. If I give UDL 0 intentionally, then obviously you are getting 0 moments. So here you are getting no member load. Here also UDL. Here point load, UDL. There is no load. This is general moment. Okay. Sometimes see these two diagrams are generally they have given wrong. So because they are asking, they know that you have to guess the questions. That's why they have given like this. So I will give some BMD. You have to guess proper answer. Okay. I will give BMD now. You just tell me which kind of frame it is. Yes. Here it's a BMD. Which kind of frame? Guess the frame.
Sir, it is subjected to a couple in the
Yes,
span
very good.
BC.
It is subjected to a
Couple.
couple. Very good. See here at A, which support?
At hinge support.
Hinge support. At D, which kind of support? At D,
Fixed support.
fixed support. Here there is no free BMD, there is no load. Here also there is no BMD, no load. Here you may get like this M. Then only this kind of moment you are going to experience. Okay.
Sir,
Now I
any
will give one more
fixed.
problem. I will give one more problem. Yes, this one.
There is a point load on the left side.
First tell me support condition.
ಎರಡು ಫಿಕ್ಸ್ಡ್ ಸರ್.
Fixed
Yes.
support.
Both are fixed. Now tell me what is the condition on column, left column.
Sir, point load near fixed load first.
Which means eccentric point load. You have to tell that it's not middle one, it's AB like this. It's an eccentric point load. Next. Here is any loading?
No, sir.
Here?
UDL.
UDL. So this is a given type of B. So like that, they may give BMD. You have to guess which kind of load pattern. They will give one specific BMD and they will ask, they will give some like this and they will add one more thing. Okay. So you have to guess on, first you have to see the support condition, then you are getting the idea. Next you have to see the member load. Okay. Any doubts? Any doubts in this kind of questions?
ಸರ್ ಒಂದ್ ಎಂಡ್ ಸಪೋರ್ಟ್ ಅಲ್ಲಿ ರೋಲರ್ ಇದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು ಸರ್?
ಏನಮ್ಮ?
ಸರ್ ಒಂದ್ ಯಾವ್ದಾದ್ರು ಒಂದ್ ಎಂಡ್ ಸಪೋರ್ಟ್ ಅಲ್ಲಿ ರೋಲರ್ ಇತ್ತು ಅಂತಂದ್ರೆ
ರೋಲರ್ ಇದ್ರು ಸೇಮ್ ನೋಡು. ರೋಲರ್ ಹಿಂಜ್, ರೋಲರ್ or hinge or simple support in any kind of structural form. The moment at that specific joint is 0. Okay, this is very, very important. Whether they may give instead of here, I may give like this. This is 0 moment. Instead of like this, I may give roller like this. If I give toe rollers or one hinge, here both the supports are 0. This is the BMD. If I can give here UDL, then it will be you are adding parabola. If I am giving point load, you are adding triangle. If I am giving UDL, one more UDL, then you are adding one more parabola. That's all. Clear? Any doubts?
ಸರ್ ಈಗ ಡಯಾಗ್ರಾಮ್ ದಾಗ ಇರೋದು ಈಗ ಇನ್ನೊಂದು ರೋಲರ್ ಸಪೋರ್ಟ್ ಏನ್ರಿ?
ಡಯಾಗ್ರಾಮ್ ನಲ್ಲಿ ಇರೋದು ಇನ್ನೊಂದು
ರೋಲರ್ ಸಪೋರ್ಟ್ ಏನ್ರಿ ಸರ್? ಇದು ಇಂಜು, ಇದು ಇನ್ನೊಂದು
ಇಲ್ಲಿ ರೋಲರ್ ಕೊಟ್ಟಿದ್ದಾನಲ್ಲ,
ಅದಿಲ್ಲ ಸರ್. ಈಗ ಮೇಲೆ ಕೊಟ್ಟಿದ್ರಲ್ಲ
ಎಲ್ಲಿ
ಸರ್ ಕ್ವಶನ್ ಅಲ್ಲಿ ಸರ್
ಕ್ವಶನ್ ನಲ್ಲಿ.
ಇದಾ? ದಿಸ್ ಇಸ್ ರೋಲರ್.
in
See,
that
this
manner.
is roller or hinge. You consider as a roller or hinge. The moment is zero alwa. ಅವ್ನು ಏನೇ ಕೊಟ್ಟರು ನಿಮ್ಗೆ ಏನ್ ಸಮಸ್ಯೆ ಇಲ್ಲ. ದ ಆನ್ಸರ್ ಇಸ್ ವಾಟ್ ಎವರ್ ಯು ನೀನ್ ರೋಲರ್ ಅನ್ಕೊಂಡು ಜಡ್ಜ್ ಮಾಡಿದ್ರು ಯು ಆರ್ ಗೆಟಿಂಗ್ 0 ಮೂಮೆಂಟ್. ನೀನ್ ಹಿಂಜ್ ಅನ್ಕೊಂಡು ಜಡ್ಜ್ ಮಾಡಿದ್ರು ಯು ಆರ್ ಗೆಟಿಂಗ್ 0 ಮೂಮೆಂಟ್. ನೀನ್ ಸಿಂಪಲ್ ಸಪೋರ್ಟ್ ಅಂತ ಅನ್ಕೊಂಡು ಜಡ್ಜ್ ಮಾಡಿದ್ರು ಯು ಆರ್ ಗೆಟಿಂಗ್ 0 ಮೂಮೆಂಟ್. ಇಟ್ ಇಸ್ ನಾಟ್ ಫಿಕ್ಸ್ಡ್. ನಿಂಗೆ ಗೊತ್ತು ಫಿಕ್ಸ್ಡ್ ಅನ್ಕೋ ಅಲ್ಲ ಅಷ್ಟೇ. ಗೊತ್ತಾಯ್ತಾ? ಕಾನ್ಸೆಪ್ಟ್ ಇಸ್ ಕ್ಲಿಯರ್. ದಿಸ್ ಇಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್. BMD ಕೊಟ್ಟು ಲೋಡಿಂಗ್ ಆರ್ ಲೋಡಿಂಗ್ ಕೊಟ್ಟು BMD.
Sir, one more thing.
Yes.
Instead of UDL, if it is UVL, how is the bending moment?
Instead of UDL, it is UVL cubic. ಏನಾಗುತ್ತೆ? The thing is, see, I'll give like this. Now, what is the BMD for this kind of structure? See, what they'll do generally, you know that you are getting all frame moments. All frame moments you are getting. But you know that for UDL, parabola. For UVL also, it is parabola, but cubic order. What you have to do, see, you have to do like a small variation like this. Full not parabola. It's not. It's like a third degree curve. It's a cubic.
Okay.
Cubic. Here you have to vary with here like this. One end you are getting here long. See, wherever the here the apex, this is a base point. At base point you are getting longer curve. At apex you are getting shorter curve. Here here it is apex, it is base. Reverse curve, here it is longer and it is shorter. You have to see there is a difference in curve pattern. If they give reverse, if they give both are in same pattern, then you are getting equal levels.
Okay, sir.
There's a small variation in cubic shape. That is in curve shape. They will get a long stretch here, a short length here. Here you are getting a long stretch here, getting a strong shorter length here. The distance, this is very very shorter towards base. Clear? Any doubts?
Sir, is it
Yes.
ಇದು WL²/9√3 ಕರ್ವ್ ಅಲ್ಲ ಸರ್ ನೀವು ಹಾಕಿದ್ದು?
ಹೌದು cubic. ಹೌದು.
Okay sir, got it sir. That's what I want to ask.
Okay.
Yeah. Thank you sir.
Okay, we'll move on to next question. The frame will sway towards. Yes, this kind of frame will sway towards which condition? Towards right, towards left. There is no sway. There is no sway. Or what? This particular frame will sway towards.
It's no sway, sir.
No sway. Any other answers?
Because both the it is fixed support, right?
Whatever it may be, all rectilinear frames are
Sways.
sway frames.
Sways.
Yes, it is towards right or towards left or data insufficient. This is sway frame. Please keep it in your mind. Always, all rectilinear frames are sway frames. Whether it is swinging towards left or right, that is my question. Any guesses?
Right.
Right.
Left.
Left sir.
Left, sir.
Left or right?
Left, sir.
Left.
Why left?
Moment ಜಾಸ್ತಿ ಆಗ್ಬಿಡುತ್ತೆ ಸರ್, ಡಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಇದೆ.
Moment ಜಾಸ್ತಿ ಆಗ್ಬೋದಾ? ಡಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಇದ್ರೆ
3 meters ಅಲ್ಲಿ ಮೊಮೆಂಟ್ ಜಾಸ್ತಿ ಆಗ್ಬೋದಲ್ಲ ಸರ್, ಈ ಕಡೆ ಆಗ್ಬೋದು ಅಂತ ಒಂದು ಗೆಸ್ ಅಷ್ಟೇ.
So left column sinks.
Left column
Sinks, sir. That's why.
Because what is the generally the if you whatever the member is fixed, it depends on fixed. If it is hinge here, then it will be a different case. But what here both are fixity, so this is length is more. Then my proper real assumption is it is swinging towards which direction?
Left, sir.
Towards the right or left?
Left.
Left. But I'll give you more to next question. You just see here. Yes, it is not the case. Okay, we will come on later words. If in case, if I am giving, see, what I will do, here I will give hinge support. Here I will give fixed support. Here. Now how it will swing?
Hinge kade sir.
Where it will swing?
Left sir, the hinge kade sir.
Right. Once again, it will swing towards hinge. Hinge is weaker support.
So less stiffness.
Hinge is weaker. It will not take moment. Clear? ಅರ್ಥ ಆಯ್ತಾ? ಅವ್ನು ನಿಮ್ಗೆ ಎರಡು ಸಪೋರ್ಟ್ ಕೊಟ್ರೆ ಲೆಫ್ಟ್ ಅಂತ ತಗೋಬೇಕು. ಇಲ್ಲ ಅಂದ್ರೆ ಈಗ ವಾಟ್ ಐ ವಿಲ್ ಡೂ, ಐ ವಿಲ್ ಮೇಕ್ ಲೈಕ್ ದಿಸ್. See, don't see the load. See the support conditions and length. How it will swing?
The right side.
Right. That's all. Because
Right.
swing is on right end. Hinge is on right end. Clear? This
Right
type
side.
of question also you may expect.
Right
So it is depends on sway is depends on basically
Supports.
sway is depends on basically the moment of inertia of the member as well as support. See, this is basically what is the general what is the moment will depends on what is the moment equation? K equals
6.
m by theta.
Theta.
What is m? K into theta. What is K?
Stability.
Stiffness is what?
Flexural rigidity.
4EI by L.
4EI by L, 3I by L, all those things. So EI means what? This one, flexural rigidity. Please keep a note, which means here, in case if I have given I, don't take length is large. That's why it will sing like this. It may be left or it may be right. It is as per your assumption. So I can, whatever I'll do, I will give one more option, either left or right. On that case, you have to pick which one?
Either left or
Either left or right. Don't say that, sir, this is 3 meters long, that's why I am taking. Length is not relevant here. Here EI plays a major role, stiffness. Here this is 2I, twice. That's why the swing takes place on left. If I will give like this now. Both are hinges, but here I will give 3I, here I will give 2I. Now swing direction
Left side.
left only. So basically one thing here, instead of hinge, what I will do, I will give fixity. Now
Right side, sir.
Right side.
right side. So you have to see the one thing, support condition. If the support condition is hinge, directly it will sway towards hinge only. Next thing is flexural rigidity of the member. Okay, this is a relation. Okay, sometimes they will ask, the sway depends on a product of stiffness and rotation, or the deformation and force. Like this they will give. Okay, the thing is, you have to say that it's a product of stiffness and rotation. Okay, clear? Any doubts?
No, sir.
Okay. The frame shown in figure, the distribution factor for the member CB, CD and CGR. Yes, please try to give the answer. So yesterday also we solved so many problems associated with this frame. Yes, fast. The frame shown in figure. What is the distribution factor for CB, CD, CG? Only one joint. Consider that joint. C joint. What are the members? CB, CD, CG. So for CB, intermediate 4 EI by L. So EI is constant, it's not given. So 4 EI by L, 4
Sir,
by
it's 1 by 3,
2.5.
1 by 3, 1 by 3.
1 by 3, 1 by 3, 1 by 3. You are getting all the same.
Yes, sir.
Okay, 4i by 2.5. But this is also 4i by 5. This length is 5, right?
Oh.
Huh? What is the sum? 4 by 2.5 into 2 plus 4 by 5. ತುಂಬಾ ಫಾಸ್ಟ್ ಆಗಿ ಅಂತ ಮಾಡ್ಕೋಬೇಡಿ, ವರ್ಕ್ ಮಾಡಿ, ಪರವಾಗಿಲ್ಲ. 1 or 2 minutes you are getting 2 full marks. Yes, what is the sum? 4 by 2.5 plus 4 by 2.5 plus 4 by 5.
Yes, sir.
4,
You're
sir.
right.
4.
4. 4, huh?
Yes, sir.
Okay, 4. Now, do
Sir,
this.
the answer will be 0.4, 0.4, and 0.2.
0.4, 0.4, 0.2.
And-
Let's check. Which one is correct? 0.4, 0.4, 0.2. Yeah. Yes, any doubts? Any doubts in distribution factor? It's very, very important in moment distribution method.
Yes, sir.
Now, instead of distribution factor, now I will put rotation factor. What is rotation factor? What is rotation factor?
Minus
Sigma
half
K.
of distribution.
Minus half of distribution factor. Minus half of distribution factor. Rotation factor RF equal minus half of distribution factor. So it will become minus 0.2, minus 0.2, minus 0.1. So the summation should be minus 0.5 for rotation factor. So summation should be 1 for distribution factor. Please keep in your mind. The summation should be unity for distribution factor. The summation should be minus half or minus 0.5 for rotation factor. So any doubts?
So it is in only in negative, sir.
Yes, rotation factor is always negative. Rotation factor is always negative. Distribution factor is always positive. Distribution factor is unity. Rotation factor is minus 0.5. Any doubts? Clear? Yes, the frame subjected to forces as shown in figure. Yes, the shape of BMD. We have already discussed. Yes, please guess what is the shape of BMD? Both are hinge. So 0. Okay, I will give, please guess.
D.
D.
Because see, 0 moment, 0 moment. This is not the case. This is not the case. This is
Option D.
possible, but here you are given negative. Why? When it is negative, instead of giving this UDL like this, it may give UDL like this, then this is the case. Okay. They have to add this one also on that case. Clear? So these 3 are eliminated. These 3 are eliminated. Hence, the answer is D.
D.
Any doubts in this question?
No, sir.
Clear? Okay. Yes.
Yes, sir.
Please guess for next question. The frame shown in figure, the distribution factor for member BC and BA is. What is the distribution factor for the member BA and BC? Yes. BA and BC. Is any answers?
0.4 and 0.6.
0.4 and 0.6. All of you getting same answer? Please check.
Yes, sir.
0.4 and 0.6. Okay. Last question. Frame distribution factor. Yes, please try to guess. It's the given frame with UDL.
One by three, 1 by 3, 1 by 3.
1 by 3, 1 by 3, 1 by 3. Which is the thing I am asking? BD here, BD, B member. I'm asking three things. BD, BC, BA. For BD, 4EI by L. For BC, also 4EI by L. For BA, 8EI by 2L. Once again, that is also 4EI by L. So the sum should be 12EI by L. If you do this, you are getting 1 by 3, 1 by 3, 1 by 3. See the answer? We are having 1 by 3, 1 by 3, 1 by 3. Yes, which option?
A.
A. Very good. That's all. A is the option. So, yes, any doubts in the slope deflection method as well as moment distribution method? Any doubts?
Sir, question 9 ಇಂದ 13 ವರೆಗೂ ಮಾಡಿದೀವಾ ಸರ್?
ಮಾಡಿಲ್ವಾ?
ಇಲ್ಲ ಅನ್ಸುತ್ತೆ ಸರ್, ಸ್ಕಿಪ್ ಆಗಿರೋದು.
Okay, we'll do. ನಾನು ಮಾಡಿದೆ ಅಂತ ಅನ್ಕೊಂಡೆ ನಿನ್ನೆ. Question number 9.
ಹಾ ಸರ್.
Question number 9. Number 9. 9. Okay.
9 ಇಂದ ಮಾಡ್ಬೇಕು.
Okay, okay. So I think it is over. Yes. Magnitude of bending moment in fixed support of the beam is propped cantilever. Is what is the value? Magnitude of bending moment. Bending moment ಎಷ್ಟು ಆ ಜಾಗಕ್ಕೆ? Propped cantilever ಅಲ್ಲಿ. Please guess. What is the magnitude?
D, B into
B. Any other guesses?
PA by 2.
PA by 2.
PA, sir.
D, maybe.
What?
option
P
D.
into
P into A plus B. What is the proper cantilever moment?
PA.
So first of all, it will be PA and matlab the moment which is acting.
Yes.
And since the far end is fixed, so the moment which will be acting at the far end, the fixed end will be half of the applied moment. So PA by 2.
PA by 2. So any other explanations from others? Any other explanations? So you are telling that B, answer B. Please think.
Yes.
Any others?
ಸರ್ PA by 2 ಗೆ A is equal to B ಆಗ್ಬೇಕಲ್ಲ ಸರ್, ಹಂಗ ಆಗೋದಿಲ್ಲ ಸರ್.
A equals B ಆಗಲ್ಲ.
A by 2 ಅಂತಂದ್ರೆ ಪ್ರಾಪ್ ಕ್ಯಾಮ್ಲಿಯರ್ ಮಧ್ಯದಲ್ಲೇ ಬರುತ್ತೆ ಸರ್.
Yes.
ಚಾನ್ಸಸ್ are PA by 2 ಇರ್ಬೋದು.
The chances are very less. What is the answer for propped cantilever moment? PAB into L plus B by 2L square is the moment generated at fixed end. But where he is asking? Bending moment in fixed support only he is asking. On that case, we have to substitute. Please consider the equation. I have given equation for propped cantilever. What is the equation given for propped cantilever? What is the equation for propped cantilever? We have discussed.
PAB into L plus B divided by 2 times of L square.
PAB into
L plus B
L plus B
divided by 2 times of L square.
L square. Or you may take like this. For bending moment at fixed support, he is asking. of proper cantilever beam. So thing is here P, here P. So what he is asking, what is the moment here? What is the moment developed here in this case? What is the M developed in proper cantilever beam? But we know that generally for it is also overhang you are having. You are having overhang. We are having the overhang. But we know that the standard equation, what is the standard equation? That is for load acting at center, we are having the standard equation. That's why if you consider moment at here, so you are getting P into A plus B for this, P into A plus B. But you are having one more reaction here. This is the reaction here. But he is not finding it's a support. It's a proper cantilever is the support here. But how we have to do? We have to do by superimposition or any other factors. We have to do superimposition or any other factors. But if you consider it as a proper cantilever, it will generate a moment. It will generate a moment P into A at this point. P into A at this point. You observe here P into A at this particular support. So when you are considering the magnitude of bending moment at fixed support, it's always whatever the moment, direct moment is P into A. P into A. That's the only direct moment acting on the entire beam structure. P into A at this particular support. If you consider up to here, it is P into A plus B. Whether the answer is 1 or 3, which one is correct?
Sir, one ಹೋಗ್ತೀವಿ sir, PA.
PA.
Yes, sir. PA is correct.
PA is correct. Why? Because whatever the moment we are taking at a prop, the same moment will act as this. When you are converting the overhang into couple, that is the only couple is same throughout the length of the beam. Whatever the type of the beam. Whatever the type of the beam, the couple acting is same throughout the beam. Because we are converting this into moment, right? P into A. We are not going to consider this kind of overhangs. We are converting that overhang into moment. We are converting that overhang into moment. Then direct question, what is the moment acting? P into A, because they have not whatever the kind of beam. Okay. The thing is, the moment, whatever we are acting directly, we have to consider that moment. Clear? It's a direct question. Sometimes they will ask, but they will ask a question like they will give a load here. They won't give this. If they give, it's direct one. It's direct couple. You are considering whatever the couple or the entire structure is same throughout. But in this case, if I am not giving this, then what is the equation for fixed end moment? What is the equation for FE final moment at this fixed end? What is the equation? If it is A, if it is B, that is WAB divided by L plus B into
2L square.
2L square. This is the equation you have to remember. I told that.
Yes, sir.
Clear? So be careful. Generally, they will ask a point load at the center of cantilever beam. Yes, the moment at fixed is also similar kind of problem. What is the moment? What is the moment?
90, sir.
90 clockwise. What is the resisting? That is very, very important. If it is clockwise, you have to consider. If it is clockwise, you have to consider
Negative, sir.
negative. Why? Resisting moment we have to take.
Yes, sir.
Okay. Resisting moment we have to consider. But in this case, they have not mentioned the negatives and all. That's why.
Magnitude.
Yes. The portal frame with all members having same EI. Yes. This is a very good question. Actually, we have solved
The
this.
10th question C na sir answer. Sorry, D na
Yes.
sir.
Anti-clockwise.
Okay.
Yes. For this, we have solved so many problems. Please guess the answer. The portal frame. Any answers? Try to solve within 1 or 2 minutes. Yes, what he is asking? MBA by MCD. That is column sway. MBA by MCD means HA by
HD.
HD.
Sir, answer is 1:2.
1:2. Any other answers? You have guessed or you have calculated?
Calculated, sir.
Calculated, huh? Okay. Yes, any other answers? Yes. So you take HA, take HD. So this is asking BA, that is HA by HD, which means MAB plus MBA divided by L divided by MDC plus MCD divided by L by 2. The thing is, what is told that it's a hinge. If it is hinge, then there is no moment. Hinge, a portal frame member of EI is same, okay. One end is fixed, okay, and other end is hinge, okay. Due to sideway ratio, what is the fixed end moment? Okay. FEM, not HAHD. FEM. What is the FEM? You have to remember. What is the FEM? Moment.
6
Minus 6 EI
delta by L square.
L square. Minus you can ignore. Nothing to worry about minus. So if it is an arbitrary frame, arbitrary, I am assuming that, then you have to see this 6 EI delta L square. 6 EI is constant. Okay. Here it will become 6 EI delta by L square. This is L, same. For divided by 6 EI delta L by 2 square. 6 EI delta get cancels. What is L square and L by 2 square? L square divided by L square by 2 what we will get? L by 2 whole square. L by 2 means
4.
this is 0.5 square. 1 square divided by 0.5 square. What is 0.5 square? L square get cancelled. So what will it implies? 1:0.5, which 1 by 0.5 implies what?
2:1.
2:1. So like that, you have to first consider this equation. 6 EI delta by L square. 6 EI delta by L square. For AB, L is L only. So EI is constant. So EI you can eliminate. So here, if you when you come to this hinge part, this is L by 2. L by 2. So 6 EI delta by L by 2 whole square. So you can say that idu 1 idre idu half. Direct age helbodalla.
Sir, L2 by square ತೆಗೆದ್ಬಿಡ್ಬೋದು sir. L2 by L1 ಮಾಡ್ಕೊಬಿಡ್ಬೋದು sir.
Sir,
Yes.
Sir, when the end is hinged.
Hinge. Yes, that's the question I am coming. If the end is hinge, what is the case?
So the moment value will be 3 EI delta by L
Yes,
square.
3 EI delta by L square. We have discussed if end is
Yes,
fixed, 4 EI by L square. If the end is hinge, 3 EI by L square. It is also direct. You are getting 3 EI delta L by 2 square. Now 2. You are getting 2 by L square divided by 1 by L square 4. So LL get cancels. It will become 1:2 or 2:1? 1:2 or 2:1? That's the question. Like
1:2.
2 divided by 1 by 4. Yes, others, it's 1:2 or 2:1? 2:1. Please check. If it is 2 by t square, right? 2 by 1 by t square. T square, or you can write like this. See, don't confuse with this kind of things. So it's in denominator. Now you can write this equation 2 by L square multiplied by this is L by 2, L square by 4.
Sir,
L square by 4. Right? This is 2 by L square divided by 1 divided by L square. Can take by 4. By 4, it will goes to up. So L square get cancels. Right? So it will remains like
1 by 4.
1 by 4. So 1 by 4.
Sir, hangala sir, 2 into 1 by 4 ಆಗುತ್ತೆ. 1 is to
2
2
into 1 by 4, yes, into 2. 2 2s are. So it will 1:2 or 2:1?
1 is to 2, sir.
1:2. Right. I think someone told in beginning only. 1:2. Yaara ಹೇಳಿದ್ರಿ ನೀವು 1:2.
Yes, sir.
Yes.
Me, sir.
Okay, good. This you can guess easily. 6EI delta, 3EI delta, 1:2. If you take ratio, if he is asking like ulta ratio, CD by BA, it is MBA by MCD. If he is asking MCD by MBA,
2:1.
2:1. So very, very careful. Okay. So if you, the thing is, you are getting same answer. If you take 6EI delta by L square, 2EI, but when you are hinge, you must be careful. It is 3EI by delta L square.
Sir, one
Okay.
confusion ಇದೆ sir.
Yes.
Sir, 10th question ಅಲ್ಲಿ ಅದು 90 ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಹೇಳಿದ್ರಲ್ಲ ಸರ್, ಅದು ಅಲ್ಲಿ ಆಂಟಿ ರೆಸಿಸ್ಟಿಂಗ್ ಮೂವ್ಮೆಂಟ್ ಬರುತ್ತೆ ಸರ್ 3 ಮಿನಿಟರ್ ಪಕ್ಕದಲ್ಲಿ. ಅದಾದ್ಮೇಲೆ ಹಿಂಜ್ ಸಪೋರ್ಟ್ ಅಲ್ಲೂ ತಿರ್ಗಾ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಸರ್ ಅದು
ಎಲ್ಲಿ
ಹಿಂಜ್ ಸಪೋರ್ಟ್ ಎ ಹತ್ರ
ಇಲ್ಲ.
ಹಾ ಸರ್, ಅವ್ರು ಕೇಳಿರೋದು ಫಿಕ್ಸ್ ಸಪೋರ್ಟ್ ಅಟ್ ಎ ಅಂತಿದೆಯಲ್ಲ.
ಫಿಕ್ಸ್ ಸಪೋರ್ಟ್ ಅದರ್ ಇಫ್ ದ ಫಿಕ್ಸ್ಡ್ ಅಂಡ್ ಅದರ್ ಎಂಡ್ ಇಸ್ ಹಿಂಜ್ಡ್. ಓಕೆ
ಓಕೆ ಸರ್, ಅಲ್ಲಿ ಇವಾಗ 30 into 3 ಮಾಡಿದ್ರೆ 90, ಇಲ್ಲಿ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ರೆಸಿಸ್ಟಿಂಗ್ ಮೂವ್ಮೆಂಟ್ ಬರುತ್ತೆ ಸರ್.
10th question are you asking? Are you asking 11th question?
10th sir.
I'm confusing. I'm seeing the 11th question. Okay, ಇಲ್ಲಿ ಹೇಳಪ್ಪ. ಓಕೆ
ಹಾ ಸರ್, ಇದು 90 ಬರುತ್ತಲ್ಲ ಸರ್, 90 ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ರೆಸಿಸ್ಟಿಂಗ್ ಮೂವ್ಮೆಂಟ್ ಬರುತ್ತೆ ಅಲ್ಲಿ. ಅದು ಏನಲ್ಲೂ ಅದೇ ಬರುತ್ತಾ?
ಏನಲ್ಲಿ ನಿನ್ ಮೊಮೆಂಟ್ ತಗೊಂಡ್ರೆ ಅದೇ ಬರುತ್ತೆ. Yes, if you are assuming anti clockwise moment, then you are getting positive moment. If you take moment at A equals 0, minus MA minus 90 equals 0. If you shift afterwards, once again that's minus 90 only.
Okay sir.
That will doesn't change. Ad change ಆಗಲ್ಲ ಅದು.
So answer anti clockwise.
Anti clockwise ಬರ್ತದೆ, change ಆಗಲ್ಲ.
Okay.
Yes, this is easy one. You can guess. Yes, guess. Yes, guesses. Fast. It's a reference O. Oh, it is 0. This is 0. 4EI by L. And this is also what? And this is what? So finally, what you are getting?
11.
8EI by L.
11EI by L.
How much?
4 plus 4 plus 3.
8EI by L, sir.
See, I think ನಿಮಗೆ ಮತ್ತೆ ನಾನು ಸ್ಲೈಡ್ ತೋರಿಸಬೇಕಾಗುತ್ತೆ. ಈಗ ನಿಮ್ಗೊಂದು ನಾನು ಹೇಳಿದ್ದೆ, ನಿಮಗೆ ಅಕ್ಕ ಇದೆಯಾ ಹೋಗ್ಲಿ? ಓಕೆ, ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ವಿತೌಟ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಲೈಡ್. I will explain. You just see here. If it is hinge, if it is like this, what is the value? 4EI by L. If it is like this, then
3EI by L.
3EI by L. If it is, there is no support.
0.
0. If it is like this, then
0.
0. This is very, very important. Now you just see why you are confusing to 3EI by L. If it is perpendicular, if it, I think I told this one. If it is perpendicular, then 3EI by L. If it is parallel at the same axis, 0. Now what is the answer?
8EI.
8EI by L. 4 plus 4. Any doubts? Any doubts? Yes, for this, what is the distribution factor for BE? Only BE. What is the distribution factor for BE? What is the distribution factor?
1/4.
1/4. Yes,
1/4.
4.
All of you getting 1/4?
Yes, sir.
How you guess this is 3EI by L? 3EI by L is 3L. So you're getting 3. 4EI by L. 3 into 3EI by L. 3EI by L means 1. 4EI by L means 1. Means 1. Here 4EI by L is 1. So 1/4, 1/4, 1/4, 1/4. Summation should be 1. Right? 1/4 or 0.25. Clear? Any doubts?
Sir,
Yes?
sir, in 12th question, I have a doubt, sir.
Yes?
Sir, ali B end ali, the support which is coming in the axis of the span, whether it's
Yes.
a hinged or roller support, sir?
If it is roller, I think AE by L.
No, sir. Actually, if the roller support is coming in the axis of the span, then it will be equal to 0, as you said yesterday.
Okay.
Yes, sir.
I want to know, now we have
We'll
taken.
discuss.
Yes.
Where it is, I think I have given in PPT or I have explained here, right? Yes.
Yes, sir. So here, sir,
Yes.
in D, you can see the roller support, if it's
Roller
coming in the
support is
axis.
perpendicular, then 3I by L. Roller support is within
In
the
the
axis
axis.
0, right?
Yes, sir.
So the
So
given
only-
question, so you are asking which support they are giving, right?
Yeah, now you have taken 0, so it's a roller.
Roller
Right? Roller.
or hinge, you have to see carefully because here the image is not clear, but they will give proper image in your examination. Which one? This one?
12th, sir.
12th. Okay. Let's see.
Yes, sir.
We'll see. Yes, it's a hinge. It's not a roller. If the roller, I think it's a hinge. It's not a roller. If it is hinge, what is the value?
3I by L.
3I by L.
11.
11.
Andre
Yes,
11
the
ಆಗುತ್ತೆ,
answer
sir.
is 11. Right.
Yes,
If it is roller,
Then
I
it will be
am
0.
not sure. I think it is roller because in my answer it is 80I by L. That's why it is roller. Because generally they will not provide hinge like this. Okay. Generally they will provide hinge in perpendicular way, because here also in explanation what I told for only I think roller condition, right?
Yes, sir.
In explanation also I have told only for roller conditions. So please go to this slide and refer this. So here you just see I have explained this particular thing for roller condition, right? So generally they will provide roller. If they provide roller, then it is 0. If they provide see OC, this kind of roller, this is very, very important. Sometimes they will ask this kind of roller, then EI by L. They can give like this also. Okay. So generally we will not give axis support as a hinge, because hinge will provide 2 vertical reactions. What happens? It will allow moment. If I provide in axial way, moment will allow it will create some that is it practically it's not possible to give such kind of structures. So generally they will provide roller. Okay. So the thing is very clear. Please keep with the concept.
Okay, sir.
Okay. Whether it is 80I by L or 11EI by L, no matters. But
Yes, sir.
please try to keep the concept. Okay.
Okay, sir. Thank you, sir.
Okay, ma. It's good. Okay. Actually, you done a very good job. That is, we have to keep as a roller, not hinge. If it is roller is in axis of symmetry, then it is 0. Generally, they will ask roller. Okay.
Okay, sir.
Okay, pa. I hope I made clear your doubts with respect to slope deflection as well as moment distribution method. Shall we move on to influence line diagram?
Sir, 11th question, sir. ಮತ್ತೊಮ್ಮೆ solve ಮಾಡ್ತೀರಾ?
Okay. ಮಾಡ್ತೀನಪ್ಪ. Wait, I got some stuck in. PPT. Okay, we'll take another PPT for work. Okay. 11th question, one end is hinge, other end is fixed. Okay. I think it is fixed, right? And you are having hinge. And this is L and this is L by 2. Right? Clear? So if it is, what is the ratio you are getting for moment? You know slope deflection equation. MAB equals MFAB plus 2EI by L, 2 theta A plus theta B minus 3 delta by L. So now we are, if you just multiply this, this is the distribution moment distribution, that is sway factor. 2 into 3, 6. 6 EI delta by L square. You are getting negative sign, but please ignore, nothing to worry about sign because the magnitude we are dealing with this kind of problems. So 6 EI delta by L square. Generally we will consider this particular thing. 6 EI delta L square for moment. We will consider as a arbitrary ratios. 1:1:1 like that we will consider. But in this particular type of problem, here you are having fixed support. Here you are having hinge support. You are going with this kind of equations, it's fine, no problem. Or you may take like, if it is fixity, 6, what is the equation? 4 EI delta L square by 3I. But we are dealing with 6 EI delta by L square. So my suggestion is always try to go with whatever the slope deflection equation will come. Okay. You nothing to worry about what is the type of support and all, because here in question, what is asking? FEM is asking or general moment? Is asking? What is asking?
FEM, sir.
FEM. When FEM comes to play, so we are not dealing with stiffness. FEM is the moment we are assuming all ends to be what? We are assuming all ends to be in FEM. What we are doing?
Fixed.
All ends to be fixed. In this kind of frame, the value of FEM is 6 EI delta by L square. So if you take this ratio, no problem, 6 EI delta by L square is L square only, divided by 6 EI delta divided by L by 2 square. So 6 EI delta cancels, will go up. So you are getting L by 2 square divided by L square, right? Or you are getting what? L square by L by 2 square. What you are getting? This is the very, very important thing. So here in denominator you are having L square. Here also in denominator you are having L square. So L square divided by L square by 4. L square by 4. So what implies? L square, if you multiply by, if you take ratio, it is L square by 4, which is equals to L square. Now in which, what is the ratio? What is the ratio? This is the ratio of what? 1 by 4 means if you take L square, it will become 4L square, or L square equals 2L whole square, or if you take twice L square outside, it will become 1:2 ratio. 1:2 ratio. Any doubts? Any doubts? Don't consider the stiffness. Stiffness is 4 EI by L, 3 EI by L. But what he is asking in the problem is asking FEM, fixed end moment. How to get fixed end moment? I think I explained in beam also yesterday class. So you have to multiply and you have to take 6 EI delta by L square. This is the fixed end moment for sway frame. 6 EI delta by L square. Clear? Any doubts?
Thank you, sir.
Okay. See, I think Rachna or Shambhavi, Yarama idu problem solve madid navu. Clear? Godaita namma idu FEM. It's not final moment. It's not stiffness. If we ask a stiffness ratio, then what is the thing? If we ask instead of FEM, if we ask stiffness ratio, what is the stiffness here? Fixed 4 EI by L, hinge 3 EI by L, 3 EI by L. You have to take the ratios. But what he is asking here? He is asking, this is very, very important. Fixed end moment. When it is fixed end moment, what is the fixed end moment generated in columns? 6 EI delta by L square. Clear? Any doubts?
Answer 1:2 ಅಲ್ಲ ಸರ್ ಅದಕ್ಕೆ
1:2 ನೇ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅದಕ್ಕೇನೆ 6 EI delta by L square ಮಾಡಿದ್ರೆ 1:2 ನೇ ಬರೋದು.
ಓಕೆ ಸರ್. ಅಂದ್ರೆ ಎರಡು ಇಕ್ವೇಶನ್ ಇಲ್ಲ ಅಲ್ವಾ ಸರ್, ಬರೀ 6
ನೋ ಎರಡು ಇಕ್ವೇಶನ್ ಬರೋದೇ ಇಲ್ಲ. ಇಲ್ಲಿ ಹಿಂಜಾರ್ ಇರಲಿ ಫಿಕ್ಸ್ಡ್ ಇರಲಿ ಏನ್ ಕೊಟ್ಟಿರೋದು ಅವನು
ಅಂದ್ರೆ 2:1 ಬರ್ಬೋದು ಸರ್ ಆನ್ಸರ್.
ವಾಟ್ ಎವರ್ ಇಟ್ ಮೇ ಬಿ, ನೀವು ರೇಷಿಯೋ ತಗೊಳ್ಳಿ, ಯಾವ್ದಕ್ಕೆ ರೇಷಿಯೋ ತಗೊಳ್ತೀರಾ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡೆಂಟ್ ಅಷ್ಟೇ. ನೀವು ಕರೆಕ್ಟ್ ಆಗಿ ಮಾಡ್ಬೇಕು 1:2 or 2:1. No matters. The thing is, if you're taking ratio MAB by L, you are getting, I think, L square divided by L by 2 whole square. Alva? So, ನಿಂಗೆ ಯಾವ್ದು ಕೇಳಿರೋದನು ಇದರಿಂದ ಇದಕ್ಕೆ ಕೇಳಿರೋ ರೇಷಿಯೋ. ಇಲ್ಲಿ 1 ಇದೆ, ಇಲ್ಲಿ ಎಷ್ಟಿದೆ? ಅರ್ಧ ಇದೆ ಅಲ್ವಾ? ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ 1:2 ನ 2:1 ನೀವು ಥಿಂಕ್ ಮಾಡಿ. ಇಲ್ಲಿ 1 ಇದೆ, 1:2 ಅಂದ್ರೆ ಏನಿರ್ಬೇಕಿತ್ತು ಅಲ್ವಾ? ಇದು L square L by 2 square. So this is the ratio MBA by MCD. Now tell me. So ಮೇಲ್ಗಡೆ 1 ಇದೆ, ಕೆಳಗಡೆ ಅರ್ಧ ಇದೆ, ಅಂದ್ರೆ ಯಾವ್ದು ಸರಿ? ಇಲ್ಲಿ 0.5 ಕೊಟ್ಟಿಲ್ಲ ನಿಂಗೆ. ನೀನು ಇದನ್ನ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೇಕು, ಯಾವ್ದು 1 ಯಾವ್ದು 2. See, L is what? If L is 2, then this is 1.
Yes sir.
Obviously 2:1 ಅಲ್ವಾ ನಿಮ್ಗೆ?
ಅದಕ್ಕೆ ಸರ್ ಡೌಟ್ ಆಯ್ತು 1:1
ಹೇಳಕ್ ಹೋಗಲ್ಲ, ನೀವು ಗೆಸ್ ಮಾಡ್ಬೇಕು. ನಾನು ಹೇಳ್ತೀನಿ ನಿಮ್ಗೆ, ನೀವು ಒಪ್ಕೊಂಡ್ಬಿಡ್ತೀರಾ? ನೀವು ಯೋಚನೆ ಮಾಡ್ಬೇಕಲ್ಲ. ಇಟ್ಸ್ ರೈಟ್. ಇಲ್ಲಿ ನೀವು ನಿಮಗೆ ಕನ್ವರ್ಷನ್ ಅದು. ಈಗ ಐ ವಿಲ್ ಆಸ್ಕ್, ವಾಟ್ ಇಸ್ ದ ರೇಷಿಯೋ ಆಫ್ MCD by MBA? Now what is the ratio? You have calculated alva, ಏನು L by 2 square divided by L square. ಕೆಳಗಡೆ 1 ಟರ್ಮ್ ಇದೆ, ಮೇಲ್ಗಡೆ ಇವಾಗ ಏನಾಗುತ್ತೆ ರೇಷಿಯೋ? 1:2.
ಓಕೆ ಸರ್.
ಈಕ್ವೇಟ್ ತಗೊಂಡ್ಬಿಡ್ರಿ. ರೇಷಿಯೋ ತಗೋಬೇಕಾದ್ರೆ ಹೆಂಗ್ ತಗೊಳ್ತೀರಿ? MCB ಇಷ್ಟು MBA. MCB ಏನಾಯ್ತು? L by 2 ಸ್ಕ್ವೇರ್ ಇಷ್ಟು L ಸ್ಕ್ವೇರ್. ಅಂದ್ರೆ ಏನಾಯ್ತು ಇಲ್ಲಿ ಅರ್ಧ, ಅಂದ್ರೆ ಇಲ್ಲಿ 1 ಇದ್ರೆ ಇಲ್ಲಿ 2 ಇರ್ಬೇಕು. ಅವಾಗ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡಿ. ಇದರಲ್ಲಿ ಅರ್ಥ ಆಗ್ಲಿಲ್ವಾ ಇನ್ನುವೆ?
ಗೊತ್ತಾಯ್ತು ಸರ್.
ಇಲ್ಲಿ ಏನ್ ಕೇಳಿದಾನೆ? MBA ಡಿವೈಡೆಡ್ ಬೈ MCD. ನಿಮ್ಗೆ L ಸ್ಕ್ವೇರ್ ಡಿವೈಡೆಡ್ ಬೈ L by 2 ಸ್ಕ್ವೇರ್ ಅಷ್ಟೇ ತಾನೇ ಉಳಿದಿರೋದು?
2:1 ಬರುತ್ತೆ.
ಅಷ್ಟೇ. ರೇಷಿಯೋ ತಗೊಳ್ಳಿ. MBA ಇಷ್ಟು MCD. MBA ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿ ಬರೀರಿ, L ಸ್ಕ್ವೇರ್ ಇಷ್ಟು L by 2 ಹೋಲ್ ಸ್ಕ್ವೇರ್. ಅಂದ್ರೆ ಇಲ್ಲಿ 1 ಇದ್ರೆ ಇಲ್ಲಿ ಅರ್ಧ ಇದೆ, ಅಂದ್ರೆ ಯಾವ್ದು ಬರ್ಬೇಕು? ಇಲ್ಲಿ 2 ಇದ್ರೆ ಇಲ್ಲಿ 1. ಎನಿ ಡೌಟ್ಸ್? ಕ್ಲಿಯರ್? ಸಿ ಈ ತರ ಕೇಳಿದಾಗ ನೀವು ಅಷ್ಟೇ ಬರ್ಕೊಂಡು ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಮಾಡ್ಬೇಕಪ್ಪ, ಅಷ್ಟೇ, ಇನ್ನೇನಿಲ್ಲ. ಓಕೆ, ಬಟ್ ಇದು ಬಿ ಕೇರ್ಫುಲ್. I made it. The thing is, I have not seen that this particular point. This is very, very important. What it is? FEM. If FEM is there, what you have to remember? 6 EI delta by L square. ಬರ್ಕೊಂಬಿಡಿ ಬೇಕಾದ್ರೆ ಎಲ್ಲರೂ. ಓಕೆ, ಇದಕ್ಕೂ ಮತ್ತೆ ನೀವು ಇಲ್ಲಿ ಮಾಡಿದ್ರಲ್ಲ ಯಾವ್ದು ಈ ಸ್ಲೈಡ್ ಅಲ್ಲಿ, ಇಲ್ಲಿ ಇದನ್ನು ಅದಕ್ಕೂ ಸಂಬಂಧ ಇಲ್ಲ. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಇದೆಲ್ಲ ನೀವು ಮಾಡಿರೋದು ಸ್ಟಿಫ್ನೆಸ್ ಮೇಲೆ. ಅರ್ಥ ಆಯ್ತಂಡ್ರು? ಸ್ಟಿಫ್ನೆಸ್ಗೂ FEM ಗೂ ಸಂಬಂಧ ಇರಲ್ಲ. ಓಕೆ, ಎಸ್, ಎನಿ ಡೌಟ್ಸ್? Any doubts? Shall we move on to influence line diagrams? It's the last topic. Okay, I will explain you. Okay. So in last series of lectures we discussed regarding so many concepts associated with structures. Okay, as per your PWD AE syllabus, we are remaining with only one major topic, that is This is very, very important and very, very simple topic. Influence line diagrams. So, and also as per your syllabi, you are having a very, the thing is, first you are having ILD for, first you are having, as per your syllabi, you are having 3 parts. One is you are having ILD for determinate beams. ILD for determinate beams. And also you are having ILD for rolling loads. ILD for rolling loads. That is, you may say the train of concentrated loads. And also you are having ILD for arches. ILD for arches. And also you are having ILD for arches. So these 3 topics, it's very, very important topic. You may expect minimum 3 or 4 questions, minimum 3 to 4 questions in ILD concept, because they are putting in 3 sections. One is for this, another one is for this, another one is for this. These 3 only remaining. So we will discuss one by one. So would you say that what is meant by ILD? Anyone? What is meant by ILD? Any idea? What is meant by ILD? Any idea? Is right or wrong? Let's please try to give answer. What is meant by ILD? ಓದಿದ್ದೀರಾ ILD ನ? Yes, any simple single point. Am I audible? ಕೇಳಿಸ್ತಾ ಇದೆಯಾ ನಾನು ಮಾತಾಡೋದು?
Yes, sir.
Yes.
Reaction, shear force and bending moment.
Shear, rear, okay. ಅದನ್ನ ಫೈಂಡ್ ಮಾಡೋದು ಅಂತ ನಾನು ಹೇಳ್ತಾ ಇರೋದು.
It shows.
Okay. ILD shows. Oh, very good. Next, any other answers? It's right. ILD shows whatever you said. It's right. Any other answers?
Variation of stress functions.
Variation of stress resultants or stress coefficients. That is, what are stress coefficients? Shear force, bending moment, or stress coefficients.
Yes.
Right? Yes. That's why it's a very, very important thing. It is also called graphical method. What is meant by graphical method? We know that graphical means using diagrams, diagrammatic, with the help of charts, with the help of ready-made charts available. We can going to find the stress resultants, that is shear force, bending moments, and those are the things. Okay, so ILD in general form we may state it as, for an example, if we consider any determinate structure or determinate beam, okay, its ILD is defined as for any determinate structures. ILD is defined as it is a line graph. It is very, very important. It is a line graph. Generally they will ask ILD is which type of graph, linear or line, or they will give parabolic, cubic, they will give few options. So ILD is always, it's a line graph. It is a line graph. This is very, very important. ILD is a line graph, or you can say that straight line only. What is meant by straight line? It is linear, straight line only. Straight line only. The ordinate, what is meant by ordinate? What is meant by ordinate? Which axis? So you are having two. One is ordinate, one is abscissa. Which one is ordinate? Which one is abscissa?
X-axis is abscissa.
Ordinate. This is abscissa. X-axis is y-axis. Generally we call it as ordinate. Please keep the mind. The thing is, they will give ordinate, abscissa like that in your MCQ. Okay, ordinate at any point. Ordinate at any ordinate at any abscissa. Abscissa gives the value of stress resultants. What are stress resultants? What are stress resultants? What are stress resultants? Shear force, bending moment,
axial force,
reactions.
reactions.
These three are very, very important. Shear force, bending moment. Due to moving unit load. This is very, very important. Due to moving unit load occupying the abscissa at any point. See, with the help of definition, I can set so many MCQ questions. With the help of only this definition, I can set various questions. See, the one question is where we can expect loads in ILD, in ordinate, in abscissa, or in neutral axis, or none of this. Where you can expect load in ILD. Where you are putting load? This is the XY graph. Where you can expect load?
On x-axis
or on ordinate?
on abscissa.
On abscissa. That is very, very important because the moving unit load occupying the abscissa. So this kind of MCQ simple. And also they may set in ILD, the graph pattern is always that is line graph, bar graph, quadratic graph, cubic graph. It's always line graph or linear graph. It's a line straight, y equal mx. Sometimes they will ask the equation. It's in the form of y equal mx plus c, ax plus bx plus c, ax cube plus bx square plus cx plus d, or none of this. Which one is correct? What is the mathematical expression for a line? Straight line. Mathematics. Y equals mx plus c or ax plus b. Right? So these kind of questions. It's a first order derivative or second order derivative or third order derivative. The line graph is first order derivative or second order derivative or third order derivative?
First order.
First order.
First order.
If you partially derivative, it's related to shear force bending moment, right? So in this particular content, you may expect several questions from SFT BMD. Have you got the things? And also this is influence line diagram is a graphical method or analytical method or any other kind of methods. Which type of method this is?
Graphical method.
It is a graphical method. Okay, now we will deal with one by one line graph. I will write very standard graph. You just take a graph and later on I will explain how to evolve those standard charts. ಸೊ ಕನ್ಸಿಡರ್ ಎ ಬೀಮ್ ಆಫ್ ಲೆಂತ್ ಎಲ್ ಅಟ್ ಎ ಡಿಸ್ಟೆನ್ಸ್. ನಿಮ್ಗೆ ಒಂದು ಕರೆಕ್ಟ್ ಆಗಿ ಹೇಳ್ಬಿಡ್ತೀನಿ ಕೇಳಿ, ಕಾನ್ಸೆಪ್ಟ್ ಇಷ್ಟೇನಪ್ಪ ಇದ್ರು ILD ಇದು. ನಿಮ್ಗೆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಸೆಟ್ ಆಫ್ ಗ್ರಾಫ್ಗಳಿರುತ್ತೆ. ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಸೆಟ್ ಆಫ್ ಗ್ರಾಫ್ಗಳು ಅವ್ರು ಕೊಡ್ತಾರ ಸರ್ ಅಂತ? ಅವ್ರು ಕೊಡಲ್ಲ, ನೀವು ಕಲ್ತ್ಕೋಬೇಕು. ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಸೆಟ್ ಆಫ್ ಗ್ರಾಫ್ ಅಂದ್ರೆ ಯಾವ್ಯಾವ್ದಿದೆ ನಿಮ್ಗೆ ಒಂದು ಡಿಟರ್ಮಿನೇಟ್ ಬೀಮ್ಸ್ ಅಂತ ಇಲ್ಲಿದೆ. ಡಿಟರ್ಮಿನೇಟ್ ಬೀಮ್ಸ್ ಅಂದ್ರೆ ಏನ್, ಯಾವ ಟೈಪ್ ಆಫ್ ಬೀಮ್ ಬರ್ಬೋದಪ್ಪ? ಡಿಟರ್ಮಿನೇಟ್ ಬೀಮ್ ಅಂದ್ರೆ ಯಾವ ಟೈಪ್ ಆಫ್ ಬೀಮ್ಸ್ ಬರ್ಬೋದು?
ಸಿಂಪ್ಲಿ ಸಪೋರ್ಟೆಡ್ ಸರ್ ಎಲ್ಲ.
ಸಿಂಪ್ಲಿ ಸಪೋರ್ಟೆಡ್ ಬರ್ಬೋದು. ಆಮೇಲೆ ಓವರ್ ಹ್ಯಾಂಗ್ ಓಕೆ, ಈ ತರ ಓಕೆ, ಓವರ್ ಹ್ಯಾಂಗಿಂಗ್ ಬರ್ಬೋದು. ಆಮೇಲೆ ಇನ್ನೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಮಿಸ್ ಮಾಡ್ತಿದ್ದೀರಾ, ಯಾವ್ದು? ಕ್ಯಾಂಟಿಲಿವರ್. ಸೊ ಮೇಜರ್ಲಿ ನಾನು ಹೇಳೋದು ಇವೆರಡು. ಓವರ್ ಹ್ಯಾಂಗಿಂಗ್ ಜಸ್ಟ್ ನಿಮ್ಗೆ ಇದು ಬಂದ್ರೆ ನೀವು ಇದು ಮಾಡ್ಬಿಡ್ತೀರಾ. ಓಕೆ, ಇವೆರಡಕ್ಕೆ ಇಟ್ಸ್ ಎ ರೆಡಿಮೇಡ್ ಗ್ರಾಫ್. ಯಾವ್ಯಾವ್ದಕ್ಕೆ ಯಾವ್ದಿರೋದು ಸ್ಟ್ರೆಸ್ ರಿಸಲ್ಟೆಂಟ್?
Shear force and bending moment.
For support reaction, shear force and bending moment.
ಇದು ಮೂರಕ್ಕೆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಗ್ರಾಫ್ ಇರುತ್ತೆ. ಯಾವ ತರ ಡಿರೈವ್ ಮಾಡಿರ್ತಾರೆ ಆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಗ್ರಾಫ್ ನ? ಯೂನಿಟ್ ಲೋಡ್ ನ ರೆಫರೆನ್ಸ್ ಆಗಿ ಇಟ್ಕೊಂಡು ಇದು ಮೂರಕ್ಕೆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಗ್ರಾಫ್ ನ ಕೊಟ್ಟಿರ್ತಾರೆ ನಿಮ್ಗೆ. ಅದನ್ನ ನಿಮ್ಗೆ ಅವ್ರ ಎಕ್ಸಾಮ್ ನಲ್ಲಿ ಕೊಡಲ್ಲ, ನೀವು ಕಲ್ತ್ಕೊಂಡಿರ್ಬೇಕು ಆ ಮೂರ್ ಗ್ರಾಫ್ ನ. ಆ ಮೂರ್ ಗ್ರಾಫ್ ಕಲ್ತ್ಕೊಂಡ್ರೆ ನೀವ್ ಇಷ್ಟನ್ನು ಆಟ ಆಡ್ಬೋದು. ರೋಲಿಂಗ್ ಲೋಡ್ಸ್ ಸಹ ಅದೇ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲೇ ಬಂದ್ಬಿಡತ್ತೆ. ಆಮೇಲೆ ಆರ್ಚರ್ಸ್, ನಿಮ್ಗೆ ಟ್ರಸ್ಸಸ್ ಇದೆ, ಬೀಮ್ಸ್ ಮತ್ತೆ ಟ್ರಸ್ಸಸ್ ಇದೆ, ಎರಡೂ ಇದೆ ಸಿಲೆಬಸ್ ಅಲ್ಲಿ. ಟ್ರಸ್ಸಸ್ ಅಂಡ್ ಬೀಮ್ಸ್ ಮಾತ್ರ ಇದೆ. ಸೊ ಟ್ರಸ್ಸಸ್ ಇಸ್ ಸಿಮಿಲರ್ ಟು ಬೀಮ್, ಬಟ್ ಸ್ಮಾಲ್ ವೇರಿಯೇಷನ್ ಇರುತ್ತೆ, ಹೇಳ್ಕೊಡ್ತೀನಿ, ಅದೇನು ತುಂಬಾ ಕಷ್ಟ ಇಲ್ಲ. ಆರ್ಚರ್ಸ್ ಈಸ್ ಆಲ್ಸೋ ಸಿಮಿಲರ್ ಟು ಬೀಮೆ, ನೀವು ಸಾಲ್ವ್ ಮಾಡುವಾಗ ನಾನು ಹೇಳ್ತೀನಿ. ಓಕೆ, ಸೊ ನಿಮ್ಗೆ ಏನಂದ್ರೆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಸೆಟ್ ಆಫ್ ಚಾರ್ಟ್ಸ್ ಸಿಂಪ್ಲಿ ಸಪೋರ್ಟೆಡ್ಗೆ ಮತ್ತೆ ಕ್ಯಾಂಟಿಲಿವರ್ಗೆ ಯಾವ್ಯಾವ್ದಕ್ಕೆ ರಿಯಾಕ್ಷನ್, ಶಿಯರ್ ಫೋರ್ಸ್, ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ ಒಂದ್ ಕಡೆ ಬರ್ದಿಟ್ಕೊಂಡು ನೋಡ್ಕೊಂಡ್ರೆ ಡ್ಯೂ ಟು ಯೂನಿಟ್ ಲೋಡ್ ಗಿವನ್ ಲೋಡ್ಗೆ ಏನ್ ಮಾಡ್ಬೇಕು ಅಂತ ನಾನು ನಿಮ್ಗೆ ಹೇಳ್ಕೊಡ್ತೀನಿ. ಅಷ್ಟೇ ಇದಿರೋದು, ಎಂಟೈರ್ ನಿಮ್ಗೆ ಇರೋದೇ ಅಷ್ಟು. ಅರ್ಥ ಆಯ್ತಾ? ಎನಿ ಡೌಟ್ಸ್? ಇಸ್ ಎ ಗ್ರಾಫಿಕಲ್ ಮೆಥಡ್ ಅಂದ್ರೆ ಏನು? ರಿಯಾಕ್ಷನ್ ಒಂದು ಡಯಾಗ್ರಾಮ್ ಇರುತ್ತೆ. ವೆನ್ ಸಿಂಪ್ಲಿ ಸಪೋರ್ಟೆಡ್ ಬೀಮ್ ರಿಯಾಕ್ಷನ್ ಅಟ್ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಒಂದು ಡಯಾಗ್ರಾಮ್ ಏನೋ ಈ ತರ ಇರುತ್ತೆ, ಇನ್ನೊಂದು ಡಯಾಗ್ರಾಮ್ ಏನೋ ಈ ತರ ಇರುತ್ತೆ, ಯೂನಿಟ್ ಲೋಡು ಅಂತ. ಅದೇ ತರ ಶಿಯರ್ ಫೋರ್ಸ್ಗೆ ಏನೋ ಒಂದು ಡಯಾಗ್ರಾಮ್, ನಿಮ್ಗೆ ಈ ತರ ಒಂದು ಡಯಾಗ್ರಾಮ್ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ಶಿಯರ್ ಫೋರ್ಸ್ಗೆ ಒಂದು ಡಯಾಗ್ರಾಮು, ಅದೇ ತರ ನಿಮ್ಗೆ ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ಗೆ ಒಂದು ಡಯಾಗ್ರಾಮ್. ಆ ಡಿಫ್ರೆಂಟ್ ಶೇಪ್ಸ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಅದೇನು ಅಂತ ಕರೆಕ್ಟ್ ಆಗಿ ತಿಳ್ಕೋಬೇಕು. ಆಮೇಲೆ ಅದನ್ನ ನೀವು ವ್ಯಾಲ್ಯೂಸ್ ನ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ವ್ಯಾಲ್ಯೂಸ್, ಅದು ಎಲ್ಲೆಲ್ಲಿ ಏನು ಅಂತ ಅದನ್ನು ಕೊಡ್ತೀನಿ. ಅದನ್ನ ನೆನ್ಪಿಟ್ಕೊಂಡ್ರೆ, ಅದನ್ನ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಬಿಟ್ರೆ ನಿಮ್ಗೆ ಅಷ್ಟೇ ಇರೋದು ಇದು. ಅರ್ಥ ಆಯ್ತಾ? ನಾವು ವಿ ವಿಲ್ ಮೂವ್ ಆನ್ ಟು 1 by 1. ಶುಡ್ ವಿ ಮೂವ್ ಆನ್ ಟು ಸಿಂಪ್ಲಿ ಸಪೋರ್ಟೆಡ್ ಬೀಮ್?
Yes, sir.
Yes, sir.
This is the last topic of your entire syllabus. AB, simply supported beam. ಸೊ ನಿಮ್ಗೆ ಇನ್ಫ್ಲೂಯೆನ್ಸ್ ಲೈನ್ ರೋಲಿಂಗ್ ಲೋಡ್ಸ್ ಅಂತ. ರೋಲಿಂಗ್ ಲೋಡ್ಸ್ ಅಂದ್ರೆ ಏನು? ಈಗ ಡೆಡ್ ಲೋಡ್ ಅಂದ್ರೇನು, ರೋಲಿಂಗ್ ಲೋಡ್ ಅಂದ್ರೇನು? ಎನಿ ಐಡಿಯಾ?
ಸ್ಟ್ಯಾಟಿಕ್ ಟು ಡೈನಮಿಕ್ಸ್.
ಸೇ ಫಾರ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್, ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, ಈ ರೋಲಿಂಗ್ ಲೋಡ್ ನ ಈ ಡೈರೆಕ್ಷನ್ ಮೂವ್ ಮಾಡ್ತೀನಿ. ಈಗ ಫಾರ್ ಏನಂದ್ರೆ ಡೆಡ್ ಲೋಡ್ ಅಂದ್ರೆ ಅದ್ರದೇ ವೇಟ್, ಅಂದ್ರೆ ಅದ್ ಮೂವಿಂಗ್ ಇರಲ್ಲ. ಅಂದ್ರೆ ಲೈವ್ ಲೋಡ್ ಅಂದ್ರೆ ಇಟ್ ಮೇ ಬಿ ಮೂವಿಂಗ್ ಲೋಡ್. ಈ ವೆಹಿಕಲ್ ಈಗ ಒಂದು ಎಷ್ಟೋ ಒಂದು 2-3 ಟನ್ ಇರೋ ಲಾರಿ ರೋಡ್ ಮೇಲೆ ಮೂವ್ ಆಗುತ್ತೆ ಅಲ್ವಾ? ಈ ತರ ಯಾವ್ದೋ ಬ್ರಿಡ್ಜ್ ಮೇಲೆ ಮೂವ್ ಆಗುತ್ತೆ, ಅದು ಒಂದಷ್ಟು ಲೋಡ್ ಇಟ್ಕೊಂಡಿದೆ. ಅದು ಒಂದೊಂದು ಪಾಯಿಂಟ್ ಹೋದಂಗೆ ಸಪೋರ್ಟ್ ಅಲ್ಲಿ ರಿಯಾಕ್ಷನ್ಸ್ ಗಳು ಚೇಂಜ್ ಆಗ್ತವೆ ಅಲ್ವಾ? ಅಲ್ಲಿ ನಿಮ್ಗೆ ಏನ್ ಕ್ವಶನ್ ಕೇಳ್ತಾನೆ, ಎಷ್ಟು ಶಿಯರ್ ಫೋರ್ಸ್ ಚೇಂಜ್ ಆಗುತ್ತೆ? ಈ ರೋಲಿಂಗ್ ಲೋಡ್ ಇದು ರೋಲ್ ಮಾಡ್ಕೊಂಡ್ ಬಂದು ಈ ಸಪೋರ್ಟ್ ಮೇಲೆ ಬಿದ್ದಾಗ ಇಲ್ಲೇ ಬೇರೆ ರಿಯಾಕ್ಷನ್ ಇರುತ್ತೆ, ಇಲ್ಲೇ ಬೇರೆ ರಿಯಾಕ್ಷನ್ ಇರುತ್ತೆ. ಅದೇ ಮೂವಿಂಗ್ ಲೋಡ್ ಮೂವಿಂಗ್ ಆಗಿ ಇಲ್ಲಿಗೆ ಬಂದಾಗ ಇಲ್ಲೇ ಒಂದು ರಿಯಾಕ್ಷನ್ ಇರುತ್ತೆ, ಇಲ್ಲೇ ಒಂದು ರಿಯಾಕ್ಷನ್ ಇರುತ್ತೆ. ಅದ್ ನಿಂಗೆ ಬರೀ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲ, ಶಿಯರ್ ಫೋರ್ಸ್ ಚೇಂಜ್ ಆಗುತ್ತೆ, ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ವಾಟ್ ಆರ್ ದ ನೇಚರ್ ಆಫ್ ದಿ ಸ್ಟ್ರೆಸ್ ರಿಸಲ್ಟೆಂಟ್ಸ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ? ಯಾವ್ಯಾವ ಸ್ಟ್ರೆಸ್ ರಿಸಲ್ಟೆಂಟ್ಸ್ ನೀವು ಸ್ಟಡಿ ಮಾಡೋದಿದ್ರಲ್ಲಿ? What are the different natures? Reactions, shear force, and bending moment. ಇದು ಮೂರನೇ ಸ್ಟ್ರೆಸ್ ರಿಸಲ್ಟೆಂಟ್ಸ್ ನೀವು ಕಲಿಯೋದು. ಸ್ಟ್ರೆಸ್ ರಿಸಲ್ಟೆಂಟ್ಸ್ ಅಂತಾರೆ ಇದನ್ನ. ಅಂದ್ರೆ ಈ ಮೂವಿಂಗ್ ಲೋಡ್ ಈ ಪೊಸಿಷನ್ ಬಂದಾಗ ಇವು ಮೂರಲ್ಲೂ ಏನ್ ಚೇಂಜ್ ಆಯ್ತು, ಇದೇ ಮೂವಿಂಗ್ ಲೋಡ್ ಇಲ್ಲಿಗೆಲ್ಲಿಗೋ ಬಂದಾಗ ಇದು ಮೂರಲ್ಲೂ ಏನ್ ಚೇಂಜ್ ಆಯ್ತು ಅದನ್ನ ನೀವು ಗ್ರಾಫಿಕಲಿ ಮಾಡ್ಬೇಕು. ನಾನ್ ನಿಮ್ಗೆ ಏನ್ ಮಾಡ್ಬಿಡ್ತೀನಿ, ನಿಮ್ಗೆ ಯಾರುನು ಅದ್ ಹೆಂಗ್ ಬಂತು, ಅದ್ ಯಾಕೆ ಅದೇ ತರ ಗ್ರಾಫು, ಅವೆಲ್ಲ ಕ್ವಶನ್ಗಳು ಬರಲ್ಲ. ಸೊ ನಾನು ನಿಮ್ ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡಲ್ಲ ಅದನ್ನೆಲ್ಲ ಹೇಳ್ಬಿಟ್ಟು. ಬಟ್ ನಾನು ನಿಮ್ಗೆ ಹೇಳ್ತೀನಿ, ಇಫ್ ಯು ವಾಂಟ್ ಐ ವಿಲ್ show you how to derive. Okay, but as an exam point of view, you have to learn what is the standard chart for reaction, what is the standard chart for shear force, what is the standard chart for bending moment. ಅದು ಮೂರನ್ನ ಕಲ್ತ್ಕೊಳ್ಳಿ ಸಾಕು. ಗೊತ್ತಾಯ್ತಾ? ಇವಾಗ ಫಸ್ಟ್ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, ಇದು ಏನು ಡಯಾಗ್ರಾಮು, ಲೋಡ್ ಗಿವನ್ ಡಯಾಗ್ರಾಮ್, ಇದು ಗಿವನ್ ಲೋಡಿಂಗ್ ಡಯಾಗ್ರಾಮ್ ಅಲ್ವಾ? ಈ ಲೋಡಿಂಗ್ ಡಯಾಗ್ರಾಮ್ಗೆ ವಾಟ್ ಇಸ್ ದಿ ಫಸ್ಟ್ ಯಾವುದು, ವಾಟ್ ಇಸ್ ದಿ ಗ್ರಾಫ್ ಫಾರ್ ರಿಯಾಕ್ಷನ್, what is the graph for reaction, what are the reaction expected reactions, ಏನೇನು expected reactions simply supported beam ಅಲ್ಲಿ? In simply supported beam how many reactions? Two. What are those? RA, RB. If I am considering RA, it will rise to unit load like this. This is 1 and here 0. Okay, this is ILD for RA. This is the equation, this is the diagram, triangle. If say this is L, this is also L. So this is the diagram you have to remember for RA. You have to remember for RA. Any doubts? Next, similarly, if you want RB, then this one. This is 1 now. This is the diagram. This is L. This is ILD for RB. ಅರ್ಥ ಆಯ್ತೇನ್ರಿ? RA ಅಂದ್ರೆ RA ನಲ್ಲಿ ಒಂದು ಯೂನಿಟಿ ತಗೊಳ್ಳಿ, ಟ್ರಯಾಂಗಲ್ ಆಯ್ತು. RB ಅಂದ್ರೆ RB ನಲ್ಲಿ ಯೂನಿಟಿ ತಗೊಳ್ಳಿ, ಟ್ರಯಾಂಗಲ್ ಆಯ್ತು. ಸೊ ಯು ಆರ್ ಗೆಟಿಂಗ್ 2 reactions, right? Shear force at any section. ಸೊ ನಿಮ್ಗೆ ಒಂದು ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಗ್ರಾಫ್ ನೆನಪಿದ್ರೆ ಎನಿ ಸೆಕ್ಷನ್ ಅಲ್ಲಿ ಶಿಯರ್ ಫೋರ್ಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಶಿಯರ್ ಫೋರ್ಸ್ ಒಂದೇ ಒಂದು ಗ್ರಾಫ್. For shear force, what I will do, I will consider here somewhere, this is the section C. I will consider this as distance A and this as distance B. Okay, artha aita iga? Idu total distance L. L is the total distance. Okay, and from A to C is distance is A, from C to B distance is B. Now what is the shear force variation? This is C point. This is the shear force variation. So this is distance A, this is distance B, and this is called A length. A by L, A by total L. This is B by total L. Please remember, this is negative, this is positive, and both are in simply supported beam. Positive. What is this? ILD for shear force at C. What I am assuming that this particular load is on C. On that case, this is the UDL. If this is here, then this is the distance here. If I am assuming is here, this is the distance here, this is the distance B. This is the standard load case, SFD. ನಾನು ಏನ್ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಈ ಮೂವಿಂಗ್ ಲೋಡ್ ಸಿ ನಲ್ಲಿ ಇದೆ ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡಿದಾಗ ನನಗೆ ಈ ತರ ಬಂತು. ನಿಮ್ಗೆ ರಿಯಾಕ್ಷನ್ ಈ ಲೋಡ್ ಎಲ್ಲೇ ಇದ್ರೂ ಇದೇ ತರನೇ ಇರುತ್ತೆ. ಬಟ್ ಶಿಯರ್ ಫೋರ್ಸ್ ಅಲ್ಲಿ ಈ ಲೋಡ್ ಸಿ ನಲ್ಲಿ ಇದೆ ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡಿದಕ್ಕೆ ಈ ತರ. ಅದೇ ನಿಮ್ಗೆ ಇಲ್ಲಿದೆ ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡಿದ್ರೆ ಸೇಮ್ ಡಯಾಗ್ರಾಮೇ, ಇಲ್ಲಿ ಟ್ರಯಾಂಗಲ್ ಆಗೋಗುತ್ತೆ. ಅದು ಇದು ಎ ಬೈ ಎಲ್, ಇದು ಬಿ ಬೈ ಎಲ್. ಸೊ ಎನಿ ಡೌಟ್ಸ್ ILD for shear force? Then the last diagram you have to remember one more chart. The chart is for bending moment. Take here the same section. It's a straight line. Idರಲ್ಲಿ ನಿಮಗೆ ಪ್ಯಾರಾಬೋಲಾ ಅವು ಇವು ಎಂತದು ಬರಲ್ಲ, ಬರೀ ಲೈನ್ ಡಯಾಗ್ರಾಮ್ಸ್ ಅಷ್ಟೇ. ಇದು ಮೂರು ನೆನ್ಪಿಟ್ಕೊಂಡ್ರೆ ನೀವು ಎಂಟೈರ್ ನಿಮ್ಗೆ ಆಲ್ಮೋಸ್ಟ್ 1 or 2 ಕ್ವಶನ್ ಪಕ್ಕಾ ಸಾಲ್ವ್ ಮಾಡ್ತೀರಾ. It is positive and this magnitude is AB by L. So this is total length L. And you know that these distances are A and B. A and B, AB by L. This is ILD for BMD. ILD for BMD. Okay. See, now I will give you. See, ಇದು ನೀವು ನೆನಪಿರ್ಲೇಬೇಕು. ನೀವು ILD ಏನೇ ಸಾಲ್ವ್ ಮಾಡೋದಕ್ಕೂ ಇದು 3 ಡಯಾಗ್ರಾಮ್ಸ್ ನೀವು ನೆನಪಿಟ್ಕೊಳ್ಳೇಬೇಕು. One is for these two are reaction. This is for reactions. These two for reactions, and this is for shear force, and this is for bending moment. Due to what? Due to unit load. Due to unit load. Due to unit load. ಈಗ ಇಷ್ಟು ನೆನ್ಪಿಟ್ಕೊಂಡಿದ್ದೀರಾ. ನಾನು ನಿಮ್ಗೆ ಈಗ ಏನ್ ಮಾಡ್ತೀನಿ, ಒಂದೇ ಒಂದು ಸಿಂಪಲ್ ಲಾಜಿಕ್ ಹೇಳ್ಬಿಟ್ಟು ಒಂದಷ್ಟು ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಿಸ್ತೀನಿ. ಇದು ನಿಮಗೆ ಫುಲ್ ಅರ್ಥ ಆಗೋಗುತ್ತೆ. ಇವಾಗ ನಿಮ್ಗೆ ಇದಿಷ್ಟು ನೆನಪಿರುತ್ತೆ ಅಲ್ವಾ? ರಿಯಾಕ್ಷನ್ ಇದಕ್ಕೆ 2, ILD ಫಾರ್ ಶಿಯರ್ ಫೋರ್ಸ್ ಇದು, ILD ಫಾರ್ ಬೆಂಡಿಂಗ್ ಮೊಮೆಂಟ್ ಇದು. ಈಗ ಇನ್ನೊಂದನ್ನ ನೋಟ್ ಅಂತ ಬರ್ಕೊಳ್ಳಿ. ಇದನ್ನ ಕರೆಕ್ಟ್ ಆಗಿ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ನೋಟ್ ಏನ್ ನೋಟ್ ಅಲ್ಲಿ? ಸಿ, ನಿಮ್ಗೆ generally you are getting point load and UDL only. It is not applicable for UVL. This particular ILD concept is applicable only for point load and UDL. If it is couple is given, you have to split a couple 2 into opposite direction force nagi ಮಾಡ್ಕೊಂಡು ಮಾಡಬಹುದು. ಕೊಟ್ರೆ ಕೊಡಲ್ಲ. This is special case. couple ಕೊಟ್ರೆ ಹೆಂಗ್ ಕೊಡ್ಬೇಕು? ಅವನು 2 equal and opposite forces ತರ ಕೊಡ್ಬೇಕು. ಅದು ಪಾಯಿಂಟ್ ಲೋಡ್ ಆಗುತ್ತೆ. ಅದನ್ನ ಮಾಡಬಹುದು. ಗೊತ್ತಾಯ್ತಾ? ಬಟ್ ಪಾಸಿಬಿಲಿಟಿ ಇದೆ, ಕಪಲ್ ಇದೆ, UVL ಇಲ್ಲ. ಅವನು ಅದನ್ನು MCQ ನಲ್ಲಿ ಕೊಡ್ಬೋದು. ILD ನಲ್ಲಿ ಯಾವ ಟೈಪ್ ಆಫ್ ಲೋಡಿಂಗ್ ಗೆ ನಾವು ಅನಾಲಿಸಿಸ್ ಮಾಡಬಹುದು. ಒಂದು ಪಾಯಿಂಟ್ ಲೋಡ್, ಅದು ಸೀರೀಸ್ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಲೋಡ್ ಇರ್ಬೋದು, ಇಲ್ಲ UDL, ಇಲ್ಲ ಕಪಲ್ ಕೊಟ್ಟರು ಅದನ್ನ ಏನ್ ಮಾಡ್ಬೇಕು? ಪಾಯಿಂಟ್ ಲೋಡ್ ಕನ್ವರ್ಷನ್ ಮಾಡ್ಕೋಬೇಕು. ಅಂದ್ರೆ 2 equal and opposite. ಅದೇ ತರ ಇನ್ ರಿಮೈನಿಂಗ್ UVL ಎಲ್ಲ ಆಗಲ್ಲ. ಓಕೆ, ಅದನ್ನ ತಲೆ ಇಟ್ಕೊಳ್ಳಿ. ಇನ್ನೊಂದು ನೀವೇನ್ ನಿಂತ್ಕೋಬೇಕು, ನಿಮ್ ಜನರಲಿ ಪಾಯಿಂಟ್ ಲೋಡ್ UDL ಎರಡೇ ಇರೋದು. ನಿಮ್ ಸಿಲೆಬಸ್ ಅಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ಹಾಕಿದಾನೆ ಅವೆರಡನ್ನೇ. ಓಕೆ, ಸೊ ನೋಟ್ ಅಲ್ಲಿ ಏನ್ ಬರ್ಕೊಡಿ? ಫಾರ್ ಪಾಯಿಂಟ್ ಲೋಡ್ what is moment? This is very, very important. Moment, MC, which is equal to load into whatever the given load multiplied by ordinate. So here, say for an example, load into ordinate. If you come to here, what is the ordinate? B by L. If you come to here, what is the ordinate? A by L. If you come to here, what is the ordinate? AB by L. If you are doing moment, what is the load? Say for an example, I am giving 10. What is the ordinate? Ordinate is the height, AB by L. That will give the moment at that particular point. Okay. Similarly, for UDL, for uniformly distributed load, for UDL load, moment at C equals load into area. Don't confuse. Load into area. Load into area for which kind of loads? For what kind of loads? For UDL kind of loads. Load into ordinate, that is height, for which kind of loads? For point load. These are the two things you have to remember while you are solving the problem. Now what I will do, I will take a simple example for understanding purpose. What I will do, I will take a simply supported beam and I will take a concentrated load of W at exactly at center, L by 2, and this is the total length L. Now I want to compute what is the value of shear force, what is the value of reactions, and what is the thing and all. Okay, first I am going to directly the moment, because moment is very, very important. The reactions are very simple. Whatever the reactions, you are getting W by 2. That is, if you just take a here, what is the intention? I am going to compute the moment basically. That's why which standard diagram I have to consider for moment? Which is the standard chart for moment? For
ILD for BMD. ILD for BMD.
ILD for
Last one,
BMD.
BMD.
That is the standard. So you just take the standard one, standard chart below here. Standard one. This will not going to alter. But you just remember that AB. But AB here L by 2, L by 2. What is this point? What is this ordinate value? AB by L. What is A? What is A? What is A?
L by 2.
What is B? L by 2.
L by 2.
Divided by L. How much? L by 2 into L by 2 divided by 2. How much? What is the value?
So divided by L, sir.
Divide by L. Yes, divide by L. What is the value?
L by 4.
L by
4.
L by 4. Okay. L by 4. This is the height. As per the concept for point load, what is the moment? What is the moment? What is the moment? Load multiplied by
Ordinate.
ordinate. What is the load now? What is the load now?
W.
W. What is the ordinate?
L by 4.
L by 4. What is the value now? MC. W L by 4. You know that it's a standard case. Now instead of W, you take W at AB. AB. Now what happens to diagram? It's a standard chart. You know that this is AB by L. As per this concept, W into load intensity
AB by L.
AB by L. What is the equation? WAB by L. Any doubts? Now what I will do, I will take some other things like UDL for better understanding purpose. UDL. For UDL, I will consider UDL. I will consider UDL. I will take this as W and this is L. What is the standard BMD for simply supported beam subjected to load? Any kind of load. What is the standard BMD? That is, what is the standard BMD? You are having chart right here. What is the standard BMD? That is a triangle only. That is a triangle only. And also the value of that particular thing is AB by L. This standard diagram I have taken L. But for MC, say for an example, MC, what is the thing? Load into area. What is the load? What is the load? W. What is the area of the triangle? Half into base is
AB.
L into height is AB by L. What is you are getting? W
AB by 2.
W L get cancelled. W AB by what you are getting? W AB by
2.
2. What is A? What is A? What is A? Exact at center. What is A? What is B?
By 2. By 2.
At center, what is A?
L by 2.
L by 2. What is B?
L by 2.
By 2. How much you are getting? MC.
WL square by 8.
Check. See. This is the concept oriented. Using the standard charts, we are going to find the moment value. Any doubts? Any doubts? Any doubts? I'm talking about moment only. Next I am coming to shear force and reactions. First I am clearing the concept. ಏನಪ್ಪ
ಇದನ್ನ ಪಾಯಿಂಟ್ ಲೋಡ್ ಕನ್ವರ್ಟ್ ಮಾಡೋಕ್ಕಾಗಲ್ವಾ ಸರ್ ಆತರ?
ಮಾಡ್ಲೇಬಾರ್ದು. ಕನ್ವರ್ಟ್ ಎಲ್ಲ ಪ್ರಶ್ನೆನೇ ಬರಲ್ಲ ಇದರಲ್ಲಿ. ಈ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಗ್ರಾಫ್ ಇದೆ ಇದು. ಇದನ್ನ ಇಟ್ಕೊಂಡು ಮಾಡ್ಬೇಕಷ್ಟೇ. ಇದು ಕಾನ್ಸೆಪ್ಟ್ ಏನು? ಫಾರ್ UDL ಲೋಡ್ ಇಂಟು ಏರಿಯಾ. ಇದೇ ಕಾನ್ಸೆಪ್ಟ್. ಗೊತ್ತಾಯ್ತಾ? ಇವಾಗ ನಾನು ಏನ್ ಮಾಡ್ಬಿಡ್ತೀನಿ, ಇವಾಗ ಫಾರ್ ಎನ್ ಎಕ್ಸಾಂಪಲ್, ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ಕನ್ವರ್ಟ್ ಅವೆಲ್ಲ ಮಾಡಕ್ ಹೋಗ್ಬೇಡಿ. ಈ ತರ ಕೊಟ್ಟಾಗ ಅವ್ನು ಕ್ವಶನ್ ಅಲ್ಲಿ ಕೇಳ್ತಾನೆ ಇದನ್ನೆಲ್ಲ. Even this is the standard thing. You have to do by using these charts only. ನೀವು ಇದನ್ನೆಲ್ಲ ಇಂಜಿನಿಯರಿಂಗ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಮಾಡಲ್ಲ, ಸುಮ್ಮನೆ ಸ್ಕಿಪ್ ಮಾಡಿಬಿಟ್ಟಿರ್ತಾರೆ. ಸೊ ದಟ್ ವಿಲ್ ಲೀಡ್ಸ್ ಟು ಪ್ರಾಬ್ಲಮ್ ಇನ್ MCQ part. GATE or IAS or any kind of competitive exam, these are the major concepts. Okay. Now what I will do like I will take a small problem for analyzing purpose. ಸರ್ ನೀವು ಇನ್ನೊಂದು ಕ್ವಶನ್ ಕೇಳ್ಬೋದು, ಸರ್ ಅವ್ನು IID ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ ಕೇಳ್ಬಿಟ್ಟು ಮೊಮೆಂಟ್ ಏನಾರು ಕೇಳಿದ್ರೆ ನಾವು ಇದನ್ನೇ ಫಾಲೋ ಮಾಡ್ಬೇಕಾ ಅಂತ. ಸೊ ಅವ್ನು ನಿಮ್ಗೆ ಹಂಗೆ ಕೇಳಲ್ಲ, ಯಾಕೆಂದ್ರೆ ನೀವು ಬುದ್ಧಿವಂತರು, ನೀವು SFDB MD ನಿಮ್ಗೆ ಹೆಂಗೋ ಗೊತ್ತಿರೋ ವೇನಲ್ಲಿ ಹಾಕಿ ಮಾಡ್ತೀರಾ ಅಂತ ಗೊತ್ತು. ಅವನೇನ್ ಮಾಡ್ತಾನೆ, ನಿಮ್ಗೆ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಓರಿಯೆಂಟೆಡ್ ಕ್ವಶನ್ಸ್ ಗಳನ್ನ ಸೆಟ್ ಮಾಡ್ತಾನೆ. ಅಂದ್ರೆ ಡಿಫ್ರೆಂಟ್ IIT ನ ಪ್ಲಾಟ್ ಮಾಡ್ಬಿಟ್ಟು ಯಾವ್ದು ಲೋಡಿಂಗ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡು, ಇದಕ್ಕೆ ಯಾವ್ದು ನಿಮ್ಗೆ ಕೊಟ್ಟಿರೋದು ಹೇಳು, ಈ ತರ ಕೇಳ್ತಾನೆ. ಅಂದ್ರೆ ಈಗ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ ಗೊತ್ತಾ, ಈಗ ನಿಮ್ಗೆ ಫಸ್ಟ್ ಇದು ಪ್ರಾಬ್ಲಮ್ ಆಗ್ಲಿ, ನಾನೇ ನಿಮ್ಗೆ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿಸ್ತೀನಿ, ಗೊತ್ತಾಗತ್ತೆ. See, for an example, what I do, I will take a load. I consider a load of 80 kilonewton and 80 kilonewton, one more 80 kilonewton at each 2 meter, 2 meter, 2 meter, for example. Okay. Now, what is the IID? What is the IID? ಕಂಪ್ಯೂಟ್ ಮೊಮೆಂಟ್ ಅಟ್ ಸಿ ಅಂತ ಕೇಳ್ತೀನಿ. ಒಂದ್ಸಲಿ ಒಂದೇ ಮಾಡಕ್ಕಾಗದಿದು, ಅದನ್ನು ತಲೆ ಇಟ್ಕೊಳ್ಳಿ. ಮಲ್ಟಿಪಲ್ ಆಗಿ ಡ್ರಾಯಿಂಗ್ ಮಾಡಕ್ಕಾಗಲ್ಲ, ಒಂದೊಂದ್ಸಲಿ ಒಂದೊಂದೇ ಲೋಡು. ಅಂದ್ರೆ ಈಗ 80 ಅಂತ ಕೇಳಿದ್ರೆ 80 ಮಾತ್ರ IID ಬರೆಯಕ್ಕಾಗೋದು. ನಾನು CD ಕೇಳಿದ್ರೆ D ಮಾತ್ರ ಸಪರೇಟ್ ಆಗಿ ಬರಿಬೇಕು. ಅರ್ಥ ಆಯ್ತಾ? ಈಗ ಫಸ್ಟ್ ಸಿಗೆ IID ಬರಿಬೇಕು. ಏನು, ವಾಟ್ ಇಸ್ ದ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಗ್ರಾಫ್? ವಾಟ್ ಇಸ್ ದ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಗ್ರಾಫ್ ಫಾರ್ IID? ಏನ್ರಿ? ಟ್ರಯಾಂಗಲ್. ಸುಮ್ಮನೆ ಬರ್ಕೊಳ್ಳಿ, ಏನ್ ತಲೆ ಕೆಡಿಸ್ಕೊಬೇಡಿ. AB/L. ಇಲ್ಲಿ ಏನು, ಇದು A, ಇದು B ಅಲ್ವಾ? ವಾಟ್ ಇಸ್ A ವ್ಯಾಲ್ಯೂ? 2. ವಾಟ್ ಇಸ್ B ವ್ಯಾಲ್ಯೂ? 4. ವಾಟ್ ಇಸ್ ಟೋಟಲ್ L? 6. ಸೊ 8/6 ಮುಗೀತು.
4/3.
Okay, whatever it may be. Now MC you want. What is MC? Load into area. How much load here? Only 80. ನಿಂಗೆ MC ಮಾತ್ರ ಬೇಕಾಗಿರೋದು. 8 into area, half into what is base? 2, 4, 6. 6 into height. Height is 8/6. 6 will cancel. 2 4s are. Now what is MC? 320 kilonewton meter. See how it is very simple. You can compute. See, it's also the symmetric. You can go and compute the thing. You are getting same answer.
Sir, I have a doubt, sir.
Yes.
Sir, ಅಲ್ಲಿ ನೀವು MC ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರಲ್ಲ, you said in when it is point load, it's load multiplied by ordinate.
Yes.
But you have
When
taken
it is,
load.
yes, yes, you are right. For when it is point load, it is load multiplied by ordinate. Yes, you are right. So
Yes,
when it is point load, it is ordinate only. Here it's
Yes,
ordinate, and here also you have to consider the ordinate when
Yes,
you are
sir.
doing MC. Okay.
Yes, sir.
Right. MC equal load. Load is how much? 80 into, for point load, ordinate is how much?
AB/L.
8/6. How much you are getting?
320/3.
How much? 320/3. And also you have to consider this one. So please don't forget, you have to consider all the diagram. What is this height? What is this height? This height, how much? See, if you consider this triangle, similar triangle concept.
Yes, sir.
This is 8/6, right? Here you are having one more. How much? This one. And this is 4 meter. And this is 2 meter. So if you do 8/6, how much? 8/6. What is the 8/6 value? 1.33 divided by
1.33.
Sir, it will be
4.
2/3.
X/2. What is X? What is X
It will
value?
be 2/3.
2/3. Okay, this is 2/3.
0.66.
Okay.
Yes, sir.
Now MC is load into ordinate. Yes, right. You are right. For point load into ordinate. For UDL
Yes,
only area. I have given both are point load. So there is no area. Okay. So MC equal, you just see 80 into ordinate. Ordinate is 8/6 plus 80 into, in another ordinate is how much? 2/3. Please do the sum. You are getting MC. You are getting MC. How much you're getting? 80 into 8 by 6 plus 80 into 2 by 3. Are you getting 160? You have to get 160. Why? If you it is a symmetrical beam I have given 80 80, the reaction should be 80 80. So at C I want 80 to 2 160. Obviously you have to get 160. For the understanding the concept I have given. Any doubts?
Sir, what? Sir, ali MC is equal to 80 into 8 by 6 plus 80 into ಅದು ಇನ್ನೊಂದು ordinate ಏನು sir?
2 by 3.
2 by 3 ಹೆಂಗೆ sir?
Similar
How,
triangles ಅಲ್ಲಿ.
Oh, yeah. Got it. Sorry sir.
See, you are getting 160, right? See, ಈ ತರ ಅಂದ್ರೆ ನಿಮ್ ಕ್ರಾಸ್ ವೆರಿಫೈ ಮಾಡ್ತಾ ಇದೀನಿ. ಗ್ರಾಫಿಕಲ್ ಅಲ್ಲೇ ಮಾಡೋದು ಇನ್ಫ್ಲುಯೆನ್ಸ್ ಲೈನ್ ಫುಲ್. ನಿಮ್ಗೆ ಏನ್ ಮಾಡ್ತೀವಿ ಗೊತ್ತಾ, ನೀವು ಇದೆಲ್ಲ ಬರ್ಬೇಕು. ಯಾಕೆಂದ್ರೆ ಇನ್ಫ್ಲುಯೆನ್ಸ್ ಲೈನ್ ಕೊಟ್ಬಿಟ್ಟು ಲೋಡ್ ಗೆಸ್ ಮಾಡಿ, ಲೋಡ್ ಕೊಟ್ಬಿಟ್ಟು ಇನ್ಫ್ಲುಯೆನ್ಸ್ ಗೆಸ್ ಮಾಡಿ, ಶಿಯರ್ ಫೋರ್ಸ್ ಇನ್ಫ್ಲುಯೆನ್ಸ್ ಲೈನ್ ಕೊಟ್ಬಿಟ್ಟು ಶಿಯರ್ ಫೋರ್ಸ್ ಎಷ್ಟು ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ. ಈ ತರ ಕೇಳೋದು ನಿಮ್ಗೆ ನಾವು. Yes, any doubts? Now I want at point D, MD ಬೇಕು ಮಾಡಿ ಸೇಮ್. Or I can ask MD ಬೇಡ ನಂಗೆ, at its center ನನಗೆ ಇಲ್ಲಿ ಬೇಕು. ಈ ಪಾಯಿಂಟ್ ನಾನು ಎಲ್ಲಿ ಎನಿ ಪಾಯಿಂಟ್ ಯಾವ್ದಾದ್ರು ಪಾಯಿಂಟ್ ಕೇಳ್ಬೋದಲ್ವಾ? I want at this point O point, I require MO. What you will do now? I require MO ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ತೀರಾ?
x/2 ಬದಲು x/3 ಹಾಕ್ಬೇಕು.
ಏನು ಹಾಕ್ಬೇಡಿ, ಹಂಗೆಲ್ಲ ಇದ್ ಮಾಡ್ಕೋಬೇಡಿ. ಡಯಾಗ್ರಾಮ್ ಫಸ್ಟ್ ಹಾಕೋಬೇಕು ಅದ್ರ ಕೆಳಗೆ. ಫಸ್ಟ್ ಏನ್ ಮಾಡ್ಬೇಕು, ಅದ್ರ ಕೆಳಗೆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಡಯಾಗ್ರಾಮ್ ಓ ನಲ್ಲಿ ನೇರವಾಗಿ ಬಂದು ಟ್ರಯಾಂಗಲ್ ಹಾಕೋಬೇಕು. ಅವಾಗ ಏನಾಯ್ತು, ಈ ಓ ಇಂದ ಇಲ್ಲಿಗಿರೋ ಡಿಸ್ಟೆನ್ಸ್ ಎ, ಓ ಇಂದ ಇಲ್ಲಿಗಿರೋ ಡಿಸ್ಟೆನ್ಸ್ ಬಿ. ಅಂದ್ರೆ ಇದು 3 ಮೀಟರ್, ಇದು 3 ಮೀಟರ್ ಆಯ್ತು. ಆರ್ಡಿನೇಟ್ ಎ ಬಿ ಬೈ ಎಲ್. ಎ ಬಿ ಬೈ ಎಲ್ ಅಂದ್ರೆ 9/6. 9/6 ಆರ್ಡಿನೇಟ್. ಇವಾಗ ಇಲ್ಲೊಂದು ಆರ್ಡಿನೇಟ್ ಇದೆ, ಇಲ್ಲೊಂದು ಆರ್ಡಿನೇಟ್ ಇದೆ. ಅಂದ್ರೆ ನಿಮ್ಗೇನು ಇಲ್ಲಿ ಲೋಡ್ ಇಲ್ಲ 0. But this load multiplied by this height and plus this load multiplied by this height, you are getting this is 0 load. Here there is no load is given. So 0 multiplied by this height 0. ಈ 9/16 ನಿಮಗೆ ಯೂಸ್ ಬರಲ್ಲ. ಇವಾಗ ನಿಮ್ಗೆ ಈ ಹೈಟ್ ಬೇಕು ಅಂದ್ರೆ, if you consider this similar triangle, this is 9/16. What is the value of this? This total is 3 meter and this one is 2 meter. Find the height. Same height will be on this side. How much? What is the height? You take this as x. X/2, which is equal to 9/16/3. What is x?
1.
How much x?
1 sir.
1. Okay, no problem. X is 1. Now y naught, that is m naught. Now I want moment, right? M naught equals 80 into 1 plus 80 into 1. How much? 160. See, how you have to check. 8 into 3 240 ಬರಬೇಕಲ್ಲ. ಎಲ್ಲ ತಪ್ಪು ಮಾಡಿದೀರಾ, ಹಂಗಾದ್ರೆ 1 ಬರಲ್ಲ. ಚೆಕ್ ಮಾಡಿ. You are not getting 1. Please check. Here x equals
0.375.
How much?
0.375.
0.375.
Yes.
This is very, very important. So then you just add 80 into 0.375 plus 80 into 0.375 plus this ordinate 9/16. This is only a calculation purpose, okay? But majorly what they will do, they won't ask like this. They will give one load. They will generally give some load. They will give here 30 kilonewton or 40 kilonewton. On that case, whatever 30 into 9/16 plus 80 into this height 0.375 plus 80 into 0.375. Okay, now that I think the class time is over, so we will discuss a few more things, few more example in next class. Here also we are getting more than 3 to 4 hours we have to spend on this topic, because it's a very, very important topic. Tomorrow I will try to solve regarding with respect to shear force as well as bending moment as well as reactions. Few more examples later on we will discuss. MCQ also. Okay, I hope this is the basic concept you have got. This is a graphical method, and we are having standard set of BMDs. You have to remember SFDs and all. Okay. So please try to practice. This is a single case I have given. Similarly, you are having for cantilever also. Okay. We'll discuss remaining topic on tomorrow. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.